Alright, think we should be live. Think we're live, guys. Hopefully everyone's having a good weekend. Just making a quick coffee here and we'll get at it. Yo, yo, how's it going there, Squeeze? Or Vep and Squeeze? That's a good coffee. Now that is a good coffee. Alright, so yeah, this is the... I like to pretend you do, yeah. This is the broken GTX 260 that it took everything off of it. Everything's off of this board. And it's just a showcase dash showing how to do soldering. So we're gonna do some of these 0608s. Right here. These little guys. Do some soldering with them. And I'm going to try my best to use the screen to do this, by the way. Normally I just do this by eye. I just use my eyeballs. And last night I did a little bit of testing. Working on a video. Did a little bit of testing on how to do soldering, what kind of tips you're looking to use for it, and what you're actually looking to see when you're doing this kind of soldering, because there are tricks to make it so that way it looks more professional. And there's a lot of people out there that have issues. I mean, even people that do a lot of soldering on graphics cards and that too, for like the extreme overclocking, they have issues. I mean, a lot of people have issues on making it look more professional. What they end up with is big blobs of solder. And there's ways, little techniques that you can do to make it so that way there isn't these massive blobs. So I'll give an example here in a second. So what I'm going to do, let's grab a little bit of flux. Which one's going to be a nicer one? This one here. Be nice to show. Like, such a little amount of flux needed for this that you don't even see it. All right, so we're going to put that one there. I'm going to make it all blobby. I'm going to show what people are ending up with. So you gotta hold that on there, line that up. Just more or less keep it inside the silk screening. Now hopefully you can see this all right. Alright, so something like that, but then when they go to clean it up, a little bit of flux. Okay, good. Glad you can see it all right. See how we got those blobs? Especially that one side, this one side here, pretty blobby. I mean, there's nothing wrong with it. It works. It technically works. But when you're starting to do these even smaller ones, like these 0102s, these really small ones here, and I'll give an example. If you want to just give me a second here. Should have one here. Yeah, right here. And these are smaller than 0402s. So here's an example. We'll put it right beside it. Can you see it? Right there, that little guy. When you're starting to do these ones, that's where these blobs can be an issue. Because if you blob it, and let's say you're using your eyeballs like I do, if you blob it, you can short this out very easily. Very easily short this out, which is no good. So this one, since it's 0608, it's a little bit easier. I mean, it's still, it's still very small, as you can see. These are just extremely thin soldering tweezers. But as soon as you go to extreme micro soldering with these little 0102s, that's when things become an issue with the blobs. So, and I'll be doing some of that soldering here soon. So what can we do to make sure that that doesn't happen? Well, for one, you can clean this up. Just by keeping your tip clean here with brass, clean that up, and just wicking it away with your tip, which will put a little bit on there. It's very hard to see, but there's a little bit extra on there. See how that is cleaning it up? But what we want to do is not have to take 20 minutes, 15 minutes, however long it's going to take to clean this up with these blob. You want to be able to do this quite quickly, right? You can do that. You can clean them up. I'll show you. I can make it look very nice just by doing this. You see how we got that little horn? I like to call them horns. I don't like it when it gets all horny. Alright, see how we've cleaned that up now? To really make it look pretty, just add a little bit of flux. Just a little bit. You don't need to go ham with the flux. There we go. And we'll hit the other side. No, I ain't pausing nothing there, squeeze. There you go. if I just grab a Q-tip here, so you always want to keep your area nice and clean. And clean this up. See how much nicer that looks? No blobby. It's on the pads nicely. Everything looks good. You can clean it up. It does take a little bit of extra time, but you don't need to do that. So everyone always adds solder, whether it be with your core flux solder here, which this is 0.8 millimeter diameter core flux solder wire. It's a 60-40. What I like to use is this bigger stuff, but I usually just add it to the tip, right? I usually just add it to it. So what we don't want to do is add solder to the component right off the bat. Adding the solder like this, you just want to add it to your work area, wherever you're going to solder to. All right? So like these pads. Oop. Starting to heat up the wire. But yeah, you're just going to add it to these pads, wherever you're going to work on. I'll show you. See how they're somewhat matte finish. Yeah, they're a little bit shiny still, but they're still like a little bit matte finish. If we add a little bit of flux to, let's say, this point here, grab a little bit of solder to our tip. See how we have a little bit of solder to that tip? Not much. And then what we're going to do is run over that spot that we're working. All right, I gotta run over this whole section here. Add a little bit of flux. See how right here, we got that little bit of a connection, just a little bit of extra flux. And you can clean that up. Like so. Now you can see the difference. See how shiny this is compared to this here? So this one that we did, isn't it what we did? A lot shinier, right? The spots that are not shiny have a little bit of oxidation on it. The side that we didn't, so this has still probably a little bit of flux on this. There's no oxidation whatsoever. It's flashed off. It's all flashed off, but you know, you can touch it without doing anything to it, basically. Like it's not going to move. It's hardened. It's flashed. It's flashed off. But these do not have oxidation yet. But if we do let this sit, it will eventually start to look like these ones here. And oxide. A little bit of oxidation. It's not much. But that's what you want to do. You want to add some solder to your pads. Now your component, your surface mount capacitor like this, we're not going to do anything with this. We're going to just hit it with a clean tip, a very clean tipped soldering iron. So I'm just going to go over here. And I switch, I use both hands when I'm doing the soldering, so I'll just flip the solder to my left hand when I do the other side. You just gotta hit that side. Alright. Like so. We're going to just hold the other side, because once you put some heat to it, you can heat up the whole component where it does desolder. So I just like to put a little bit of pressure, not much. Like we're talking like basically the weight of the needle, these little tweezers. Just not much. You don't want to hold it again. Just put a little bit of weight onto it. And then just hold this component together. Like that. Alright, so now that's soldered onto place. And I can show that here. I move the whole board. To make it even cleaner, though, make it more professional, you just add a little bit of flux. You don't need much. Now we don't even need the tweezers either. You could just go in and just touch the one side nice and flat. We can go into the other side. Like so. And we can clean up our work area. It's that easy. It's not too hard to do, and it literally looks professional, right? See how nice that is? Soldered on there nicely. No blobs. It's prep work. All of soldering is mostly prep work on where you're working. All right. So if you have these oxide spots and you don't add any flux, it can make it so that way it's a lot harder for you to solder tube as well. As in it'll be bubbly or have holes in the solder joints, and that's no good. Struggling two wires together there, Squeeze. It's a lot of people think, you know, there's tricks to soldering wires too, and I can show that here as well if you want. Show you an easier way to solder wires together. Like, how are you soldering the wires together, by the way? So this is kind of the thickness of wire you would use for like when you're doing your headphones. And then we'll just not shake the table too much here. Give me one sec. Now move this. So I got an area here. So you got your wire there, right? Now the trick with the wire is a little bit of flux again. A little bit, I mean barely any. You don't need much. You're just trying to get rid of some of that oxidation. And then we got, let's say, our solder. You're going to hold your soldering tip to this wire. And then you're going to get your solder wire, if you're using solder wire, and you got to press that to the wire. All right. Once it flows into it, you got a nice little solder joint. And what you could do is just add a little bit of flux to it if you want. Add a little bit of flux to it. And just hit it with the soldering iron again to clean it up. Alright. And that's how you solder wire. The thicker the wire, the more powerful your solder needs to be, or you're going to need a thicker tip. Thicker tip will help a lot, because the thicker wire will soak up a lot of heat and transfer it to the rest of the wire. Thinner wire is very easy to do, though, in my opinion. It's also kind of like if you're, let's give me a sec here, I'll grab another piece of wire. So I'll grab a thick piece of wire here. So we got a thick piece of wire here, right? This is a tinned copper wire, so it's already silver, but there's no actual solder on it. what you're going to want to do is add solder to your tip, like so. And you're going to hold this to the wire until you see it soak up. Till you see it soak it all up. Then what you can do is just add a little bit again, a little bit of flux. Clean up your tip. And just clean up that wire. There you go. Like so. Now that's all tinned up, and that will make it easier for you to do soldering. Like solder this to another component. And let's say like another component onto like this motherboard. Well, it's PCBs, not motherboard, but it's just PCB. Again, a little bit of solder, a little bit of flux and solder onto that. See how that. Oh wait, showing it, yeah, right here. See how shiny that went. Grab the side that you added that solder to. The trick is to warm the wire to that solder, and it will sit down and hold itself into place, like so. It's a nice solder joint. It's not bubbled up anywhere because you're prepping everything. It's prep work is the key for soldering. Same thing with welding. If you're trying to do welding, prep work. It's always prep work that makes the soldering or the welding a lot easier. So we'll just clean up this here. There we go. That's the main thing you want to do. So let's say we're soldering a bigger component. And I'll give you a little tutorial on silk screen in here. See how we got this C717? The C is going to be capacitor. So even on our smaller spots here, C709, right here is going to be another capacitor. And that would be like the one I've already soldered on. One of these 0608s. Let's go back over to here. This one is our tantalum capacitor, surface mount capacitor. So, one of these. Right here. This will go into place there. All right. A little bit different, yeah. Yeah, I mean, anything for soldering and stuff like that, it's always going to be a prep work. Or for doing cars and that, for like harnesses, it's generally your connection points. So you're going to be using self-soldering connection points or just terminals of some sort. And a little bit different, but also it's prep work. You got to make sure your wire length is a decent wire length, and you make it look good and all that. I like to make stuff look kind of professional, do more of a professional style work. So what we're gonna do here, again, add a little bit of flux, a very little amount. And make sure you have a nice clean solder tip. And you see how shiny those are now. They flashed off, but they're still very shiny. We're going to have a very little amount of solder to the tip. Very little amount. Don't need to go ham. Let me go over here. hold this into place in between where it's showing for the silk screening. Like that. And a little bit of the solder off of the tip went onto the component and hit the solder underneath and connected these 2 points. Then what we want to do is just press a little bit down and solder that across like so. And then to clean it up, it's a little bit of flux here. Clean solder tip. Like that. Again, clean solder tip to the other side. Like that. And if we take a look, it's connected to the point very nicely. Connected to the point very nicely. Not too difficult to do, it's just prep work. Yeah, your soldering tip here there, and why I say to keep your tip clean. See how this is looking? All this oxidation onto it, whatnot. Yeah, try to focus that a bit better. Give me 1 sec here, I'll try to focus it a bit better for you. See that though? See how it's not looking so pretty? Then if you're going to use your brass, these always come with your cheap kit. You just brush it around really good. Now you see our soldering tip? See how nice that looks? See how nice and shiny that is? That's what you want. No, you don't sand. Don't sand your tips. Sanding it can actually cause issues with soldering tips. Especially if you're gonna get better, like nicer soldering tips too. You put sandpaper to it, you just ruined it. Oh, thank you, man. No, thank you. Put another light on. Another light on, show you. And this right here will stay nice and shiny for a bit, and then we'll start to oxide, and that's when you want to clean your tip again. And then if you let them sit and whatnot, you can get tips that look like this. These are like little needle nose style. This is for more for like the 0102s. These are nicer for them. Although I find with that hoof tip, if you're just quick, it's easy. And you got them if they're sitting around. This one's, see how it's rusted and we got that high point? Like it's all rough looking. This tip was used for a very long time, and this can happen. A little bit of solder just goes up into it and then it does this. This tip is still good, it doesn't look it. Always try to put your tips away with solder too, for storage, like until next time you're doing work. I can clean this one up and it'll look brand new again. No, that tip, it was, oh my god, it was such a good one. It's like this. It's like this one. It was a little bit stubbier. That was such a good one too. Like, oh my god, its thermal transfer was amazing. Like, actually amazing. That's why I need to get more tips. It was like this one. It crumbled on to me, and I'm wondering if the indium solder, if it was part of the indium that ate away at it. It literally ate away at it. So yeah, my one tip literally crumbled on me. But yeah, prep work is key for this kind of stuff to make it look, really good. Again, a lot of people have that issue where they're getting the bubbles and whatnot. It's just if you're getting that bubbles, you're not prepping proper and you're using way too much solder. A lot of people don't realize you don't need a lot of solder. And sometimes they use too much flux, and then yeah, that also doesn't help if you're using too much flux. Just a little bit. Surface mount need very little. Cool cars and tips. So I'm going to show another one right beside here for anyone that's just joining. I'm going to do one here and show you what I'm talking about, the comparison between the two. So let's say we do add a little bit of solder to that, or flux to that. I'm going to grab our little SMD, little capacitor. And let's say we go in from the other side and we are going to use our very small wire. I'm probably going to cover up the... and try not to here. 1 sec. Let's say we are going to use our soldering wire here. There you go. See how we got that horn? We add the flux. You usually end up with a blob. Right? You usually end up with a blob. Yeah, see how not pretty that is? This is what we don't want. We don't want this big blob. Or that horn. No good. This is what people end up with. Does it work? Yes. Is it pretty? No. Is it using way too much solder? Yes. We hold this to this. Should be able to pull this off. Oh, maybe not. Right? No good. There we go. We're gonna clean this up. Add some flux. Not bad. Clean up some of this flux off of where I'm not working. So that way it's not going to harden up later on and be a pain to clean up afterwards. Dang, eh? Vep the loan shark. No, it's not that easy. Unfortunately, it's not that easy. So now we're going to do, again, the proper way of how to solder this on. Again, a little bit of flux. Clean the tip. And we're going to add a little bit of solder to it. A little bit of solder to the tip, not much. And then hit the spot we're going to work on. Like so. Get it nice and shiny. No oxidation. Oxidation's bad. And a little dab of flux. We go in there, we're going to set it with the one side. So right here, like so. Alright. Go into the other side. Again, hold down. No, you don't have to, press hard. Just hold it down a little bit. Hit the other side. Like so. Little bit of flux. There you go. Grab a Q-tip. Clean it up. Looks perfect. Every time. Every time. Oh, wow. Yeah, it's no good. Fraud is no good. Fraud can make things a pain for you, though. To a fridge and wash machine? Dang. Yeah, 2 for 1. Okay, so we'll desolder this component now here. The little tantalum polymer capacitor. To do that, I'm just going to hit with a little bit of flux on both sides here. What I'm going to do is gently put some heat to it here and gently pull up while trying to remove the solder. So clean tip, go back to it, and hold the tip to it and then pull away, and you're getting a little bit of solder on the tip each time. But since you did it properly putting it on, there's not much solder there, so it's a lot easier to remove. Now you might have a little bit of solder left on this side. That's okay. Because what we're going to do, because since this actually moved very little, and we're going to take your time with these, because you can wreck the actual terminal points on these. So you want to do the other side. Very little. Clean the tip. Add flux if needed, if it's not sticking to your soldering iron. We go back to the other side here. And we're going to hit it again, and we're very gently trying to pull this up, right? Just very gently. And this should be now loose. Clean the tip again, because again, you took away that solder, so it went onto the tip. Go to the other side here. There you go. And our component is still perfect. Alright, our component's still perfect. And you can see how well the contact was on these pads. Right? So having a practice board could be very beneficial for you as well. And then you can see how well your actual soldering skills are before you start working on something that is actually worth some money too. So, grab a Q-tip, clean up this solder, or flux I mean. Clean that up, clean up our surface. Get rid of some of this cotton off of this too while I'm at it. There we go. It's good to go again. Go back over here. Yeah, the old fridges are they last, but they also are very inefficient. Very inefficient compared to nowadays. Okay, so let's do. You want like a baby? I got nothing for you. So now what we want to do is try to find 3.3 volt section here, somewhere over here. Oh. Use a piece of paper to help keep this nice and flat. Here, I think we can see it. Yep. So these are right here. It's a 3-point voltage regulator. Generally diodes go here. And these are generally 3.3 volts. For graphics card, they can be 5 volts as well, though. And some of them 1.2 volt, 1.8 volt. Majority are going to be 3 volt, though. Those are right here. This little guy. Right here. Yuff. It says your PC isn't good enough? Yeah, right. That's this right here. Let's go solder onto this side, though. It's a little bit easier to show. Which one? This one here? Yeah, we'll do this one here. Right here. So again, what you want to do, little bit of flux. Clean your soldering tip. Add a very small amount of solder to the tip. We're going to prep this work right here, like so. Alright, like so. Clean your soldering tip again. Grab the piece that we're working on. Flip this around. And we're gonna now flip it. There we go. Put this into place like this, which just matching the pads is what we're doing. Matching the pads here. I'm really trying to use the screen when I do this with eyeballs, so a little difficult for me. Right. Yeah, I need a little bit of flux too. Oh god. Oh god. The flux grabbed it. Line this up nicely here. Well, try to line that up nicely. There we go. Hit the front side and the other pad. And the main thing that you're trying to do with this as well is trying to put the heat right onto the actual terminals, the actual component terminals to the pad, because those terminals have to reach a certain temperature to melt the solder, so that way it can actually attach itself. Like so. They haven't programmed it to recognize 50 series cards. Really? Nah. Your PC's basically overbuilt for Skyrim, even with mods. This one's a little crooked. A little crooked. I don't like it. That's what I'll do. A little bit of flux. Soldering iron. I'll just hold this to it. It'll heat up the component. Yeah, some solder to it. Yes, adding solder to remove components is very helpful. Just adds a little bit of thermal mass, basically. Any more flux. Looks like we're gonna need a bit more. I'll hit the other side. Should be able to pull this off. Apparently doesn't want to let go. Come on, baby. Please. Please and thank you. I know you wanna. I know you wanna. I know you wanna. I know you wanna. Come on. There you go. And a little bit of flux, clean up this area that we just took away that component. Voila. Get rid of the old flux. A point tip. So, if you don't have a high-end soldering machine and high-end tips, using a hoof style or a little bit larger of a diameter, you're gonna find. I can show you. Hold on. Actually, I'll just show you. It's gonna take a minute for the soldering iron to cool down there, but I'll show you. I'll show you. So we will use a point tip. Like this one. Alright, we'll use this one. Which will technically work for this, right? Right? Oh, you use the chisel. You use this. No, don't be using this. Don't use the chisel tip. Not for this. Now the chisel tip can work pretty good for doing your wires though. Don't use a chisel tip when doing micro soldering. Now, if you want, let's say, to prep your board area, the chisel tip. Which one are you talking about? That's a chisel tip. This is a hoof style. A crescent moon hoof style, whatever one you want to call it. Smaller. I don't have any of them. I don't have anyone that's smaller. Still don't use that one. Don't use that one. So the hoof style is a better one because you see how it's angled when I'm holding it, and I can keep my hand on the ground. So I can keep my hand on the ground. And see how it's angled towards that and it's flat to the component. Right? Oh, let's move this up like this, right? We're angled towards the component. A little flux. Clean this one up even a little more than what it is, even though it looks really good. Right? So see how we're angled? And we can just touch this to it. Right? And then we can go to the other side, and once we, again, I just flipped to a different hand. See how I'm angled towards this, and I'm also angled upwards away from the board, so that way the soldering iron doesn't touch any other component than what I'm actually working on. Right? Nice, gotta play some scattering. Right? The hoof styles is very handy. It's got good thermal transfer too. And when you want to do soldering on with these kind of components, you don't want to saturate the heat into the component. You just want to be able to touch and leave. As in just solder it to place, and that's it. That way you're not thermal transferring a lot of heat to the component because the heat will wear it down or can corrupt it, make it faulty before you even get to use it. Soldering iron is almost cooled down now. I'll switch over the tip and show you why I prefer certain ones. And I'm guessing the chisel tip you're talking about, maybe I do have that one. Where did I put it though? That's the question. Where would I have put it? Ah, found it. And you're talking about what? This one here? This chisel tip? I still don't like this one. Because you gotta hold a certain angle to the component. And it's very annoying. You gotta lift up and arm positioning. When you're soldering, you want to be as steady as possible. Very steady. So you're not accidentally hitting a component off. Yeah, angled, yeah. So you want that angle. You do want that angle. So what I'm going to do here is flip over from the hoof style. Go. And we'll go to pointed tip. We'll do some 0102 soldering, which is the smallest you'll ever work on. That basically anyone will work on. Alright, so now we got the pointed tip for the 0102 soldering here. We'll do here, and we'll solder. Actually, we'll do this one or this one. Actually, don't matter. Don't really matter. One of these. We'll do one of these. Might need a bit of tip tinner. I didn't put this one away properly. Actually, no, I think we'll be alright. We will be just fine. to grab one of those little 0102s. So one of these little guys. Right there. You gotta put a little bit of flux there. A little bit of flux will help this stick to that too. It's probably very difficult for you to see this little guy. Well, that's not what I want it to be. Oh no. All right. It's one side. Do the other side here. Of course, we just moved it. Let's do the side first then. I have to grab my other tweezers. I'm gonna have to grab my other tweezers here. Yep. I've got my other tweezers, I just can't hold it proper. I have these ones semi-modified for 0402s and up. Just holds better. Need to grab these ones, which are extremely pointy. A little bit of flux to this. That's why no one really wants to do soldering on 0102s. They are a pain. It's one side. There's the other side. Grab your Q-tip and clean it up. It is slightly on an angle. I'm not too happy about that. I'm trying to use the screen. I don't generally use the screen. I'm working a lot farther away than what I generally would. Clean my tips off here. There you go. How's it going, Maz? I need some flux. I need some solder. There we go. Just had to re-prep apparently. There we go. That's very difficult to see, so give me a sec here. There we go. That looked a bit better. Clean up all the extra solder or flux that we got here. Ah, we got some cotton on it. We got some cotton on it. Oh no. Yeah, the 0102 suck to solder. So if you can use a certain tip that's going to solder quickly to it as well. That prep was key, always key for this. I need some coffee. Oh yeah. What else should we solder? Show how to do bigger surface mount, more like your tandem capacitors, uh, 0608s, 0102s, and also did a diode. Just give me a second here. I'll be right back. Yo, Nugget, watch your feet. All right. Yo, it's Joe. How's it going there, Joe? All right, let's do another one of these. We'll do beside that one. Like that. A little bit of flux. Oh, wait, not a little bit of flux. I am switching over the tip. I'm just showing how to do nice soldering because a lot of people have issues, and I'll show here in a second again. Should have left them on. A lot of people have issues with when they're soldering these components, these smaller components. They're getting blobs of solder. It's all blobby looking, and a lot of people have issues with that. So I'm trying to show people how to mitigate or make it look more professional. And then showing how to do these 0406 or 0608s, these ones here, which are a bit larger. And I've shown how to do smaller, which is over here. Right here, which are 0102s, which are very, very small. As you can see, these are the size of the tip of my tweezers. And showing how to do that. Showing how to solder on like a tantalum capacitor, surface mount. And also showed how to solder on a diode, 3-point diode. So I'm just going to switch over the tip here quick. I'm using a OSBot, or OSBot, I call it OSBot, OBS bot. So if I wanted, I can control it to look at certain parts of the board if I wanted. The PTZ camera. And I just have it set up in a certain way so that way I can show the soldering. I got it very cheap years ago. Very cheap. They had a sale and a coupon on Amazon. They're like $250 Canadian now. 300-ish, right around there. I got it for a lot cheaper than that. And I just gotta wait for the soldering tip to warm up here and I can show how to do this. It's about a foot away. It's zoomed in all the way. What I can do to make it even look better is, since I have it set up on a tripod, is I can do this so it's a bit closer, like so, and then I can unzoom. Go this way, like that, so it's a bit closer. A little bit different angles, so that way you can see a bit better too. Then I can zoom right in. There you go. And we'll focus on a spot that I'll be working on. Put a little bit brighter here. Like that. as well. Manual focus. That way it's always looking good. Because I'm zoomed in too, so close. If I move the table around a little bit, it does shake a bit, but that's okay. There we go. Let's do this spot here. Right there. That's where we're going to solder next. So we'll add a little bit of flux. Clean up the soldering tip with your brass cleaner here. Make the tip look all nice. Grab a component, a 0608 MLCC ceramic capacitor. And I did not add any solder to the tip. Alright, so we can hold this in position. Exactly where we want. Hold it nicely in there. A little bit different angle. There we go. It's way off. There we go. Hit the other side quickly here. Like that. And what I'm going to do is just add a little bit more flux to it. Clean up the soldering tip again. And we're just going to lightly touch this side. Alright, lightly touch it. Bam. Clean up the soldering tip again. And just lightly hit the other side. Oop. Got too much heat on the board there. Now I got. You gonna make it? There we go. Now you'll see that there's a little bit of a bump there, whatnot for now. That's okay. I'm gonna reposition this though. Like that. See how it's not looking exactly perfect. I should set up the camera so it shows a little bit better, but I'm gonna go in, touch the other side. And that. Hit this with some flux. And hit it again. Now the flux, as you can see, really cleans this up. Now what you might need to do on some of them is add a little bit of solder to it. When I say a little bit of solder, I mean a little bit of solder to the tip. As you see, like that little bit. There's not much. Now you'll end up with this. Okay? This is what a lot of people end up with. That's okay. That's not an issue. We'll do the other side. You gotta clean up the tip. Again, add a tiny amount of solder to it. Right? Just a tiny amount. Yeah. See how nice that one went? Because there's still a generous amount of flux to it. So that's why it ended up looking perfect basically there. That's fine. Clean up the tip. Clean up your tip again. Clean it all up so there's nothing on it. Looks nice and perfect. You just gotta add a dab of flux. Just a dab. And what you gotta do is just touch the solder. Is all you're gonna do. Alright? Like that. Try not to touch the component too much, just more or less touch the actual solder itself, and the flux and the solder will solidify and be perfect basically. Or not solidify, melt. It'll melt. Then we gotta clean up the area where the flux might have been. Take a look. Let's just do autofocus for a second. So you take a look. How nice that ended up. When it's nice on there. Yep, this is the donor board that I took every component off, so that way I can just have a board to show how to solder to certain components. Like, again, very small, the smallest components you can think of, the 0102s, which are the very, very small ones here. Like here, 0102s, the smallest you'll ever solder to, and most people won't even solder these components. And a little bit larger ones, which are the 0608s, which are more common. Then you got 0402s. And the 0402s are, if I can find it on this board, there's not many 0402s on this board. Yes, right here. And over here. There's 2 spots. Now, when I was because this board here, it's shorted on the internals, or the core itself is dead core and it's shorted. So I took everything off of it. When I was taking off some of these right here, I was just quickly taking them off, as in using a little bit of heat and then a soldering iron and just quickly running it over. And I did it a little too fast on some spots here, unfortunately. And then when I showed yesterday, was it yet? No, 2 days ago. I showed how to take off memory chips, and they're perfect because I took my time. I mean, it was like 7 hours of desoldering the rest of the components, and everything is really nice on the rest of the board. Very, very nice. There's some spots that are they're darkened. Yeah, it's darkened. It's not like it's melted, the board's burnt or anything. It's just old flux that have been set in and heated up many times. I just did not do enough cleanup. That's my own fault there. So I need to get some isopropyl in the future and fix that up. But yeah, there's 2 torn pads on this core side. And then you could fix these pads. So if I right around there, or the corner there, I could attach a wire, put it to, and coil it, and then add it to it, solder mask it, and then scrape it away. And I can make a new pad if I wanted. And I can show that in the future, how to do that too. How to make that. It's not easy. It's not for beginners. And you need to make sure you have a steady hand. Like you got to have a steady hand doing this kind of small work, for especially the 0102s. These 0102s are very not fun. Just showing how to do soldering squeeze. That's why. And I'll desolder these too. I'm gonna desolder all these again. I just figured I would show people how to do some soldering. People do like soldering videos and whatnot and tutorials, so figure why not do it live. I mean, a lot of people don't do stuff live because it takes them a long time to do it, or they do a lot of messing up, I don't mind. If I mess up on screen, I don't mind it that much. I really don't. It's always a learning experience. Even if you got experience doing something, you can still learn more. So a lot of people don't realize. It's like doing these small ones here, having to switch over to a different tweezers. Like these tweezers here, I have these ones set up. See how they're slightly angled? I put a slight angle into them, and I made sure that they're not super pointy, so that way they can grip these larger ones a lot nicer and hold a certain angle, so that way I can keep away from other components. And then I got these tweezers, which are extremely pointy and very nicely done up. And then I got these ones as well that I've semi sanded down to be fairly pointy, but not too pointy. These are actually really good for holding on to these diodes right here. Really good for these diodes right here. Because then you can hold it up like this. And then when you're holding these components as well, what you don't want to do is hold it so that way you're touching the board. You want to hold the component up a bit. So it can be very difficult sometimes to do. You want to hold it up so that way you can put a little bit of pressure down on the board, so everything's nice and flush. Yep. I mean, I've had videos and I've done live streams and modding cards, so more or less trying to find the data sheet, reading the data sheet for what's good to modify. Nuggy baby, you okay? What? Hi. What's up? You just talking to yourself? Okay. Yeah, well, not right now. Not right now. Can't go on my lap. Soldering. I don't want to burn you, just in case. Yep, I'm just showing how to do soldering. And then I'm going to do a solder, which a lot of people end up with now. Alright? I was supposed to do that on the last one, but I didn't. Sec. Move these capacitors over. Go. So we'll do, now as you can see, some of these spots here are starting to dull here, right? They're dulling down right here. These pads, they kind of look dull. Before you start doing your soldering, when you got these pads here, what you can do is add a little bit of flux to the work area. You're going to clean up your solder tip, add solder to it. And, you know, it doesn't have to be a crazy amount, a generous amount. And then what you're going to do is run over those pads, okay? See how shiny that is now? The pads that are dull, they're semi-oxide. And then you see how these are nice and shiny. You got a nice little ball onto it. That right there makes it so that way that's enough solder. That you don't need any more solder than this amount. This tiny little amount of domed up solder is all you'll ever need to do these soldering on these SMDs. And then you're going to clean your tip. You're going to add some flux to it. Not much, just enough to wet it basically. You grab your component, line it up to where it needs to be. I'm using the wrong tweezers. Okay, so hold that over to it. And generally I don't use the screen. I'm using my eyeballs always for this. So I'm trying to use the screen, and I don't know how people do it. Use just the screen. So like that. And when you're holding your capacitor, these small points, remember you're trying to make sure that you're holding it so that way you're not flush with the board when you put the piece down. Okay? So put this over here. It keeps wanting to flip on me. Alright. Yeah. Lightly hold down, not much. You see how it's lifted up because of that little bit of a, because we got solder there. Just go hold this to it. Give me a second. Clean up your tip, because you're going to pull away some of that solder too when you do that. You will pull some solder away. And it's preheating the component and the solder when you're doing this. So now we can grab that, put it back into place. Sit more flush, but not where I want it. That. I'm just flipping hands, that's why. If you're not like ambidextrous at all, just flip the board around. It's not a big deal. All right. We're gonna add some flux. And then you're just gonna hold down. What you can do as well is just use one point of the tweezers or both. And it's just, you're lightly just not, you don't need much pressure. You don't need much pressure on this. Like just a little bit. Put the soldering tip to it nice and flush. Clean it away. That piece is on an angle though. Clean up the tip again. And go back to the other side here. That side looks really good. It is flat to the board, but it doesn't look it because it's a little bit of an angle there. But a lot of people end up with this. Give me one sec. So a lot of people end up with this. That's one side. Either some horns. We can get rid of the horns again easily, right? We can always get rid of the horns, not like it's an issue. Right? Get rid of the horns. And then, as you can see, the horns on this one's really large. what happens if we just, yeah, big blob, compared to, right? That's what a lot of people end up with. These blobs. These blobs. The blobs are no good. And yeah, if we come in with the soldering iron, clean the tip, come in with the soldering iron, clean it, come back in, clean it. Like that. See that one side looks pretty good now. And if we come in with the soldering on this side, again, clean your soldering tip every single time. Eventually, it looks better. Eventually. What I'm gonna do, lower the heat down here. Right. Come back in with the soldering iron. Clean that up. It does take time to clean up your work if you're not doing it properly, or if you're just okay with that blob. But a lot of people are not okay with the blobs. I don't care. I don't like the blobs. I like to make sure it looks really good, right? So that's pretty good there. What we can do, and clean up the piece. We got a nice, better looking, no big blobs. Yep. I'm trying to show with soldering iron though. Not everyone has a hot workstation. Yeah, it looks better without the blob, and it's you can go through a lot of solder. You can go through a lot of solder. I know in a way solder's cheap, but it's not. There's a lot of different kind of solders you can get, and some of it's very expensive. The lead-free solder is pretty expensive. Lead-free solder also wears out your soldering tips. It's a lot different than leaded. PB-free is generally what you're gonna want to use for certain components. Yeah, I don't care for doing both at the same time. So why I don't like to do both sides at the exact same time, you're heating the component way too much. You want to do it as quickly as possible. So using a little bit of extra heat than what you normally would is just fine. There's no issues with that. So just give me 1 second, I will show you how long it should take for you to solder this, to do it proper. So we'll do this one here, up here. We'll just add a little bit of flux. Again, what we're going to do, clean the soldering tip, add a little bit of solder to it. Not much, just a little bit. Right? And then we're going to do this. See how shiny that is compared to everything else, right? It's not oxide. It's good to go. Clean up your soldering tip. Grab your component that you're soldering. Yeah, line it up nicely, right? Line it up real nice. Right? Perfect. Wherever you need to put it, and you're just gonna lightly solder, right? Just lightly, quickly. Very quickly. And you don't need much flux either. Like we'll add a little bit of flux to it afterwards. Like that. That's connected. Perfect. Looks very nice. A little bit of flux. You just gotta lightly hit the one side. Like that. You hit the other side quickly. Like that. You're done with the soldering. You're gonna take your Q-tip and you're gonna clean the component and any flux that's around. Alright? Like so. And you see how nice, not a whole lot of extra solder, very quick work to do. Very, very quick. And the longer you take on this component is the more time that this component is going to have heat get soaked into the actual component. Now these components can handle a fairly high amount of temperature, but the longer you put heat to it is more temperature, more heat per time, which is actually going to wear it out. And you don't want to wear these components out. You want these components to last, right? And you see how nice this is. Very nice. Then other times you'll get people doing it, it's a little bit of a blob. You don't want the blobs. The blobs mean you're using too much solder. Always prep. Prep your work. See how, again, these are matted finish. If you see that it's somewhat looking dull, go over it quickly, add a little bit of flux, and then a little bit of solder over top. Like I said, this is why I really like the hoof when dealing with this, the hoof style, because it's flat. It's a flat tip. You can run over those pads nicely, add a little bit of fresh solder, it gets rid of any oxidation. Boom. Yes, lead free. PB free is a little bit harder to work with, of course. I use, so sometimes, not all the time, I don't generally use the core flux water solder, which is I have 0.8 millimeter diameter. I like to use this 50/50. This 50/50, I like it. Is it the best for electronics? No. But if you're doing it like this, where you're not doing crazy amount of, extra solder to it, it's actually really good and doesn't actually need a whole lot of heat. Yeah, yeah, yeah. And this stuff here is lead free. This stuff, this core um, core wire. It has rosin flux inside of it. Already has flux in it. And yeah, it does take. It's a little bit worse on your tips for one, and generally needs a little bit more heat. That's why it's a little bit worse on your tips as well. Yeah, I need to get more flux. I'm running out. Well, I still got technically a lot, but not a lot of 8341 I like. And I've had this container here of 8341 flux for a very long time now. And it's just getting old. Still works just fine. It's just not the best. I would like to get some better flux for sure. Yeah, ceramic caps you technically can. But let's say you're working on should have a spot for the caps here. Where are they? Yeah, right here. So flip the board over. Again, it doesn't look the greatest. It's old flux and all that onto it. I have to clean this board really good. Again, this is just a board I took every component off of because it has an internal short, just to show how to do soldering and just like a showpiece more or less. But yeah, there's some spots that are darker, and that's just old flux. That's all it is. It's very hard to clean without isopropyl and a scrub. Yeah, let's say you gotta add in some can caps, right? Can caps you have to solder one at a time. You could try to do both, but you need a pretty beefy soldering iron for one to be able to do both at the same time. But it's always better to do one at a time because you want to make sure the flow is going all the way out and then like all the way through. Nice solid connection basically. And then I'll show how to get rid of any extra solder that might actually be in it, like that. And there's solder in these ones too. You just can't really tell. Yeah, I'll show how to do that sometime as well, how to use a sucking tool. And they got electronic sucking tools too that are apparently pretty good. I would like to try them sometime. Like these smaller ones, like I said too, like these smaller 01, 02s. You don't want to hold your solder iron to it because this will get heat soaked so quick and start wearing it out very, very quickly. And got cotton still on it. Yep. Yep. You gotta be careful with caps. You gotta cover them up. I generally use just a piece of aluminum to stop the heat from hitting them when I'm doing hot air. Hot air is very, very useful. But doing this kind of soldering, like with these, I always use soldering iron. I don't use hot air. Yeah, that's actually a good idea. That's actually a good idea. Use a tin's or well, it's aluminum can. Yeah, that's actually a good idea. I got fairly thick aluminum chunks I got from work years ago. I just use them, cover up places. And I have videos out there showing what happens when a capacitor explodes from heat. Oh my, it can be pretty brutal. Sounds like a firecracker too. Oh, it's the can caps you worry? Yeah, yeah. Your aluminum polymer. Your aluminum polymer caps here. It's gonna focus. Focus! Focus, yo, fire. There you go. Those ones you're worrying about. Yep, these can go. And how these ones go, because as you can see, there's no cut marks. There's like indents generally on some. I'll show you here in a second. How these ones go is they get squeezed out. That's just flux on it. They squeeze out. So this compression right here, they squeeze out and it fires the whole can. And they stink. These ones stink. Then I got these other ones here. Here's some nice Panasonics. These are nice Panasonics. See how we got that cut mark on it? These ones generally will explode through the top. And it helps mitigate the actual explosion. Sometimes these can still peel. So basically this casing over top of it will peel and it will actually still shoot up and explode very violently, but most times they'll be just fine and actually explode to the top, which is not too bad. Oh yeah, they can be pretty brutal. These ones are not so bad. And they got that compression as well, but these ones have the cutouts, which is nice to have. So it's not so violent. Same thing with the smaller aluminum polymer caps here. That's gonna focus. There we go. 16 volt 270s. These are pretty violent too, because there's no cut marks anywhere or indentations that weaken the actual casing. Yeah, yeah. Yep, and it's nice to have those ones for certain electronics for sure. Because if that aluminum polymer cap right here, if this goes and it does fire this cap, let's say there is still power to some of the board somewhere, and this short circuit somewhere else, it can destroy more than just the cap, which would be no good. And doing modifications on GPUs, you're gonna have to solder a lot of wire all the time. So, like a piece of wire here, 30 gauge. And what you gotta do is you gotta add some solder to it. So just add some solder to your tip of the soldering iron, and you're gonna just touch the there, pre-tin it. Always gotta pre-tin these. And you, most of the time, you'll hit like the ground point and add a little bit of flux to this. Like that, to make a good connection. And then this wire would go to somewhere else, like to a potentiometer. Like to a potentiometer here. Which is just a variable resistor. Yep. I use this small wire to do to jump traces and to jump stuff. Sometimes when you're doing graphics card, like overclocking or modifying graphics cards, I'd say, to get rid of certain overcurrent protections or over voltage protection onto the chip, you're gonna have to jump the ILIM and the what is it? It's definitely ILIM and another component, and it's not ringing a bell right now for some reason. You have to jump those two connections together, and I just use a piece of wire that I tin up and then cut it very small, smaller than this, very, very small, because it's going to be generally like an 0102 or a 0406. Generally is a 0102 or of some sort, and you got to jump these two connection points together, one for ILIM and another one for, I can't think of it, I don't know why. It's another connection point that you gotta add together to get rid of the over voltage or over current protection. It's generally over current protection on some chips that are left open, and that you can connect the 2 points together, and it automatically gets rid of over current protection. So, and you're gonna have to do that on certain controllers, PWM controllers, like the 5388, NCP 5388. C245 tip versus C210. Cat drama. Mine's laying by my feet because she's She's wanting to lay in my lap, but I'm busy. So now we'll grab another component here. We'll solder that on. And we'll do it right here, right beside that one. A little bit of flux. We'll go over these pads. There we go. They're all shiny. Clean up the tip. Put that beside. Line it up wherever you need to line it up. I've moved it. There we go. And looks like we're going to need a bit of solder because it's not enough. So we'll add a little bit of solder to the tip. A little bit of flux. Run that over the pads again. There we go. Little domes. Little tiny domes. Not a lot. Again, little is your friend. As little as you can do. Line these up. Like that. There you go. Go to the other side. Go back to the other side. Make sure this is pushed down nice and flat. Again, not a whole lot of pressure. You don't need a whole lot of pressure. You want it as steady as possible so that way you're not shaking all over the place. Because if you hit this, let's say it does somehow desolder the other side because it's thermal transfer, you'll move the piece. So just a little bit of pressure, hit that. Like so. And then we're going to go in with a little bit of flux again. Clean up our soldering tip. And I don't need tweezers anymore because we're just barely going to touch the component. Alright? Barely touch it. Go to the other side. Like so. And what we're going to do, grab a Q-tip. Clean up any solder around that area. Old solder is no good. It makes the surface sticky, and you put heat to it as well. It can make it so it's very dry and very, very difficult to work with or clean up. There you go. Nice, perfect little solder joints. So the main thing that we're trying not to do, again, main thing we're trying not to do is get like these blobs. We want them to look as clean as possible. So once you start working on these smaller components, a little blob can turn into a short because these components are so small. They're so small. That little blob, you won't even see it if you're not paying attention sometimes. A little blob can go from one trace to the other, or one pad to the other, or even over top of the component. So you want it to be as clean as possible. No blobs. We don't want blobs. Even this is still blobby. Yet there will be some people that have even worse blobs than that. Prep is king. Little is more. Little is more. And this is solid, 100% solid. Same with this one here, and same with this one here. Nice and solid, not going anywhere. Very clean. And then when you want to add on extra capacitor on top of this, it's also very easy to do. So what you got to do, add a little bit of flux on top like that. You got to grab our component, because adding capacitors when you're doing modifications to graphics cards can be very beneficial. And basically you want to be able to do that as well if you're going to do below, like, really cold temperatures, very cold temperatures. And then we're going to grab our component here. We're going to set this on top. So you have to line this up. And what you can do as well when you're lining this up is push this down, so that way this component, you can use the tweezers to line it up and hold it flush on either side. Alright, so take a look, and we're just going to lightly touch these components together. And go to the other side. Check your tip, make sure there's no oxidation onto it. Clean it up if you have to. Nice and shiny is always what you want. And go to the other side. Just lightly hold the top. Like so. Now if you have any little horns that can happen on these, you just add a little bit of flux. Grab your tip, clean it, go over to it, and again, you're just going to lightly touch the solder. Alright, that's it. You don't need to do anything else more than that. And as you can see, the tip got that little bit of solder onto it. It's very hard to see, but it's got that little bit of solder on the tip. Any extra could flow into the solder that's already there, make the connection a little bit thicker, but mainly it will go onto your soldering tip. As long as your tips are pretty good, in good shape. That's why you keep them clean, keep them pre-tinned when you're not using them. Now we take a look after I clean it up. Because this is what you will want to do when you're doing modifying graphic cards or motherboards or anything else, is stack another capacitor on top. Now you don't want to go past just one stack, because then you're causing issues. Alright, so clean that up. There you go. Take a look. Nice, perfect. And look on this side. Gotta love that. And there you go. Now this is connected to the top of this. And again, you're going to want to be able to do this for modifying graphics cards. And then making it as nice as possible. Not have this go over one side or the other. We'll make it so it's easier for one to solder other components or stack other components as well. So, again, take a look here. See how nice that is. They're nice and flush. Everything looks really good. Right? You might need to do that. So there's little techniques for that again, as I showed. Little techniques for that. So you gotta hold your component, right? You hold it to the top, and you can slide the tweezers down onto the other component that's already there. And then when you have these domes on your piece, it can make things a little challenging. All right, make things challenging. So let's grab our component here. Let's go on to this one here. You set that on. Make sure it's lined up nicely. Get your tweezers and then hold it so that way it's not moving. And then you can angle it like that. And that's holding it so that way it's flush on either side, and holding it so that way you can solder to it. Alright. So we'll do this one again. We'll just add a little bit of flux to it, like this. I'm going to grab our component here. Clean up our soldering tip. Again, nice and shiny is what you want. You hold this component to it. Set it down like that. Now see how it's not perfectly aligned yet, right? It's not. That's fine. That's fine. You can just set it there. You can set it there, and then we can hold this component to it by this, holding the whole thing to it like that. Hopefully you can see this. All right. See how we're nice lined up. We can line it all up nicely, and we can hit this with some heat here. Oop. That. Right. We can go over to the other side. Again, check your tip. If it's not shiny, it's no good. Clean it up. Go off to the other side here. And all you need to do is put a little bit of pressure. Not much. Like, we're talking the weight of the tweezers is enough. And to make sure you have a steady hand, you're not using a lot of pressure too, right? And you hit the other side. Now what I'm going to do, add a little bit of flux to it. I'm going to go back to the other side. Oh, apparently I wanted to do that, which is okay. Not a big deal. What we can do, put it back on. Now sometimes your components too might not have enough solder. So what you can do, just add a tiny amount to your soldering iron. I mean, a tiny amount. Right? Just a tiny amount. And then hold this, put it to where we need to be. Like that. And then might need to position it a little better. Oop. Apparently I wanted to stick up. Still getting used to using the screen. I do this usually by eyeball. Line this up better. Like that. And what I'm going to do, just to help with the soldering and whatnot here, is add a little bit of flux. And I got to clean up the tip again. There we go. Fairly good. Not on there as nice as I'd like, though. Is this one, right? See how it's slightly off? I stepped away for him. I think someone came back to see you talking about solder on the tip. Yeah. So that's why using certain tips. That's why I like to modify some tips to help out with this kind of stuff. Because when you're stacking chips, stacking these MLCC caps right here, right? You got to do, well, I mean, if you're doing this for modifying your graphics cards, this is just making it so that way it has a little bit more capacitance over the core. Helps with filtering, helps it so like load and all like that and you can get more frequency, more overclockability by adding caps. Go. Go to the other side. Oh. Held on to it too long. Stop doing that. Stay. Stay. Line that up. Yep. Yep. You can do that too. Generally though, when you do something like that, you do need to make sure you have good tweezers for that as well. And again, the amount of solder you need is very, very little. Gotta move the heat. I'm melting my finger. Would like to invest in a hot plate. I don't want to get a cheap one though. I would like to get a little bit better of one. There we go. There we go. I can be a bit steadier now that I'm not melting my finger. Ceramic tweezers. Never thought about getting ceramic tweezers. Never thought about getting ceramic tweezers. Are they pricey? I'm guessing they're pricey. Not by much. Yeah, I would say ceramic would be pretty good. I have to add a little bit of solder to the one side. Go. Flux, get rid of this horn. Bam. That was a pain. I just have a light amount of hot air on the top of the board, so I gotta position it a certain way so that way I'm not melting my fingers. Yeah, add a little bit of solder to it. I had enough solder onto it, but because how many takes that was, because I couldn't keep steady. And there you go. And generally, I'm not using a screen. I'm doing a screen. I usually just use my eyeballs, and I'm very quick on doing this just by eyeballs. I don't care for the dragging up. As you can see, it's good. It's good. What I'll do is just angle the flat tip and then just do a rub. A rub generally works good, and it pulls off a little bit any extra solder. Up works. Let's say you don't have enough flux on it too. If you pull it up, you can flip it over, and then it's just scrape away that solder. Yeah, it's nice and soldered. It is. One sec, I'll show you. See? That one actually has too much, that side. That one has too much. At least in my opinion. It's there. It could be cleaned up a little bit, add a little bit of flux to it. Make it look even better. It's quite difficult to get. Not all these capacitors are perfectly the same size either. So having it, like, see how there's like that little step right here, like very, very little amount. It's hard to get sometimes it'd be perfect onto it just due to the fact the capacitor size might be a slight difference than the other one. Yeah. Yeah, I would leave that too. Like, this is perfect in my opinion. Good enough. Does look like it could, a little touch up, a little bit of flux, and just a touch with the soldering iron would clean this side up a bit. This side, in my opinion, does have a little extra, which is fine, having that little extra. At least it's not like one of these ones, right? Where it's all domed up, and if you dome it up onto the next one, which I could show too, is like domed up to the next one, you're losing distance to solder and get a good angle onto these other components, which could be more of a pain to solder these ones if this is all domed up. You're losing surface area. You're losing work area, basically. Makes it harder for you to find an angle for the tweezers. Yeah, and that's where that pull method can come in handy. I definitely hear you there. Yeah, definitely can help. Held it for too long. I was even thinking about using the tweezers for this. For that last touch. Oh. It's doing BIOS for Chromebook. I saw the tiniest register. Yeah, that's these ones here. 0102s. 0102s. I've already shown that. How to solder those ones. Yeah, these are a pain, and you gotta make sure you have a decent pair of tweezers. Nah, you won't get smaller than 0102s. 0102s is the smallest you'll get. At least that I know of. What's smaller than an 0102? Of course. It would have to be 0102. Those are the smallest ones that I know of. I don't think they even make smaller. Oh, I need flux. Need flux. I might have to add a little bit of solder on this one. Maybe not. Maybe not. And generally, this is a lot easier for me to solder when I'm not trying to show people how to do it. I'm working pretty far away from where I generally would be working. It's a bit of a reach. So I would like to get a microscope at some point. So that way it's like I can work comfortably. A little bit of an angle on that one, but not bad. Yeah, let me know. Let me know what's smaller than 0102. Yeah, 0102s are small as I know. And these tweezers here have been sharpened, as in I sanded these ones down as well. So it's literally like a grain of sand. Not easy to solder them. Well, you gotta have a steady hand. Really steady. Yeah, the 01005 are just no 01005s are larger than what I'm showing here. Yeah, yeah. Which are they're 0402s that you're talking about. These are 0102s. Oh, sorry, no, these are 0402s. My apologies. These are 0402s, which are smaller than yeah, they are what you're talking about. Well, they're not what you're talking about. They're 1005s in metric. These are 0402s. My apologies. I'm saying these are 0102s or not. Or these actually can be 0201s. Actually, yeah, these could be 0201s, which are 0.6 millimeter by 0.3 millimeter. Yeah, 0201s. My apologies. I know these are the smallest ones I've ever seen, and these are, you set them down, you can't see them by eye. Unless you're looking very, very close. What's up, Nuggy? Yeah, either 0402s or 0201s. It could even be 0102s. Because they're fairly similar in size. Like it's only like a point few millimeters more. And then you got really more common ones that are like I said, 0402s, which are really small, which people don't like working on. 0608s. Yeah, yeah, very small. If you're not looking close enough, you won't see this by eye. Especially this color too. It's kind of annoying, this color. And then you got the resistors too. If you give me a second, I'll show you a resistor, because that's an actual cap. Smallest cap you'll find. And you got resistors that literally, careful with those ones too. Do I have one? Yeah, I do right here. Okay, there you go. Generally, they don't use incredibly small on like on there you go. Yeah, there we go. On graphics cards or any kind of like motherboards, but apparently on laptops they will. And this little guy here. That's also incredibly small. 1 or 2 years, yeah, yeah. It's crazy that they're actually using that, because they're more or less for throwaways. Like you won't generally find people that work on this kind of small soldering. Yeah, yeah. This right here is like an 0402, which is again very small. Yes, it's very small, but it's not the smallest. Even this is people don't want to work on. Seriously, like people just don't want to work on them. is because they're so small. And temperature really matters with these too, because you can overheat them very quickly. An 0201, an 0201 and 0102s are not as common, that's for sure. More common are going to be your 0402s, which again are very small. Yeah, if your tweezers stick together, those ones are actually alright. These ones, no, those ones are like butter. Like this one here has like a tiny amount of pull. And then all I do is just hit it with some heat. And then what I also will do to help out, just grab your soldering iron here and just grab it with the tweezers and do a light small pull. And I'll see how we got a little bit of flux there. I'll melt it right off. Also heat up the tweezers, and there's no more grabby. That's all I'll do. And as you can see, it cleaned it up a bit too. When you're generally working like on preheated boards and that, when you're doing with the, that's why a little bit of flux goes a long ways too, because your tweezers won't stick together and stuff like that either. Oh, it's less likely to start sticking together. And what we can do is get rid of this little guy. Go shiny. That's why working on heated boards too, like as in you got a heater or light amount of heat to the board. It's nice too, because when you set down your component, and when you let go, generally it will let go, right? You have to add a little bit of solder to the tip for this one. And put this over here. So, there. All right, have a good one, Joe. Thanks for stopping in. That. I'm gonna need a little bit of flux. Clean up the soldering tip, so that way when we clean this up, we don't add any. We can pull off any extra to clean it up. That. Don't need much. Same thing with this side here. That. Don't need much. Clean up a little extra bit of flux. so we're not going ham with it. Good solder connections, not all bubbly. I could have lined it up a little better, but that's fine. And generally, if you're going to be working on doing this kind of, doing these components, and you need these capacitors, and they will be capacitors. See how we have the silk screening? The C, it's for capacitor. You're going to solder this component on, or you can solder these two components on first and then do these bigger ones. So that way you can do it in a series. Basically, you're just going to keep going on, go on and on. Not just solder a whole bunch, cover up where you need to solder more components, because then the angle of your tweezers and the soldering iron become more of a job, basically. Makes it a little bit more difficult. And then if you do have hot air, I mean, you can get yourself some low melt solder, just put it onto the board, basically put it on the board, add in your capacitor, hit it with a little bit of hot air, and it'll go right perfectly into place. You don't have to use tweezers or anything like that. But hot air is it's a bit of a job itself, a little bit of a learning curve for that as well. It's not just hop to it. A lot of people have troubles with the component flying away. Well, you're using too much air. You're not angling the air straight down on the component either. If you angle the air right with just the right amount of air, you're generally gonna be more. Remember, less is always more when soldering. Less is more. What should I solder now? Because I've already soldered enough of these capacitors. What should we solder? And if we go over to show different part of the board here. How's it going, Dab? So now we got R and a Q. What's an R and a Q on a silk screen? Q, Q, R, Q. Then we also got some U's. Then we got a D. Your D, and you can see that it's 3-pin. Your D is going to be diode. Yep, D is going to be diode. Yes, correct. Q is usually a transistor. Yes. What about U? So we got D, diode, Q, transistor, R, resistor, U is what? A, yes. And as you can see, you're correct. How we know that you're correct? A U is generally like an 8-pin power IC or BIOS because it's 8 legs. 1, 2, 3, 4, 5, 6, 7, 8. It's some sort of logic controller that's 8 legs. BIOS or a lot of components you can actually use for it. It's not going to show over there for 14 pin. And then we got another U. This is a smaller one. This is power IC. This is a power IC, where this one is. These ones over here, larger, more or less going to be for your BIOS. Can be another power IC. I have the components here. Give me one sec. No, this one have the silk screen for the PWM. No, it does not. Alright, so we got this. And that will go which way is it marked here? I have to clean it up. Give me one sec. I gotta clean it up. Nobody I can see. There we go. So on the silk screening, put that over. On the silk screening here, there'll be a dot of some sort to indicate direction. The direction you'll have to put on for the little dot. On top of this, which is not shown very well on camera. There's a little, it's either a recessed dot on top, right here, or it'll be a silk screen, an etching of some sort. This right here is the indicator though. And it goes on like this. So you gotta line up this dot with this dot over here. And this is a silk screening dot to show location. Now you also got triangles to help as well for some. These right here that you see, this one and this one, are actually probe points. This is actual silk screen. It's a silk screening. These are probe points. These are solder. These have solder. These ones. This is actual silk screening. That's why I can easily rub over it. And then these ones over here, it's actual solder. That'll help you put directions for it. And that would be the same thing for your PWM and other components, which could be your 12-legged, 14-legged controllers as well, which just has some sort of logic in it. Now to do those too, it's not too difficult to do. You can just add a little bit of flux. Add your controller. Add a tiny amount of solder to your tip. Actually, what I'll do beforehand too, take that off. Run this over. Like that. So that way there's no oxidation and whatnot. I'm going to line this up nicely. Like that. Pre-tin it. Let's do it. It's so far away from me, so I can't really see too well. Just to make sure his legs are lined up nicely there. Make sure those are soldered in nicely, right? And then what you can do as well, if let's say you do add too much solder, and I can show you here. I don't know why I just added that. Let me just get rid of that extra flux. I wanted to show a point on this here. So let's say you add on too much solder, right? So I'm just gonna get rid of this flux now. Let's say you add too much solder. Right, so you add too much solder. That. All right, whoa, look at all that solder. All right, and you're shorted out now. Don't freak out. You don't need to freak out at all. You can just relax. You can add a little bit of flux to it. Alright, add a little bit of flux to it here. And let's see if I can turn this so you can see it better. There you go. You're just going to add that flux and then run over it with your soldering iron. It'll grab that solder. And then you can clean up your tip again. Add a little bit more flux. And then just run this over it again. And it cleans it all up and makes a good solder joint. Clean up your solder tip. Just gotta flip this board around here. Add a little bit of flux. Yeah. And that's solidly on there. Good and solid. You don't need to add a crazy amount of solder to it. Pre-tinning the pads with new solder is really good and beneficial. It's more than enough generally for your contact points anyways. Let's say you do add, again, too much solder. You just add a little bit of flux, run it over your tip lengthwise onto it, just run it over it, clean up your area. I could have put this on a bit better, but couldn't see it too well. That's it. Fairly easy. You don't need any hot air or anything like that. All right, just give me a minute here. Oh. Alright, sounds good. Make some food here. What? Not good. That's a pretty good burrito. A pretty good burrito. Right. Needs to be cleaned up. I need some heat on it to clean that one. Alright, just give me a minute here. Should make myself another coffee. No what? No. Myself a coffee here. Do a bit more soldering. Ugh. If anyone's joined in, anyone's joining in and wants to ask some questions, let me know. Show you some more techniques for soldering nicely. I got a bunch of comparisons here. I don't have a big blob one, but I got a bunch of comparisons on here where, you know, a little bit of a blob, but not too bad. Nice example. It's a little off, but it's still on pads, not shorted type deal. Good example. Stacking. Then sometimes when you're stacking chip or MLCC capacitors like this, when you're doing modifications, some capacitors might not be perfectly the same size. So you might see a small step. Not a big deal though. Get my booklet back underneath. Make sure it doesn't move around. There we go. Nope, I thought I got mine. Got ourselves another cap here. And we'll put this, now put it there. Again, a little bit of flux onto the work area. Clean solder tip. So use your brass, clean it up. Run over your surface. Need a little more flux there. Nice and shiny again. No oxidation. Coffee's ready. Let's go. Come here, coffee. Not bad. Not bad. Pretty good. Alright. Alright, so we got that nice shiny surface area that you prepped up. Right. Clean up your soldering tip again. Line this up. And we might need a little bit of solder. Just the tiniest amount of solder on your tip for doing these small components, and a very, very little amount. Yeah, line that up. I need a little more solder. Line that up really good. Again, it's okay if you got a little bit of a horn. It's kind of hard for you to see the horn, but if there's a little horn, not a big deal. And go on to this side here. And just put your tweezers on top. You don't need to hold it anymore. It's already been soldered in one spot. And what you're going to want to do is a little bit of flux on top. Clean off any extra solder that you have on your tip. And that horn, as you can see right there, the little horn, it's very difficult to see, but you can see it. Just going to touch that horn. Alright. Your second run in, what you can do, either pull sideways, add a little bit of flux, just touch that side again, like that, and go to the other side. Alright, go to the other side, a little bit of flux. And get rid of that horn. And clean up your area. As long as you don't go too ham with the solder and end up with this. We'll make what generally people are doing and having troubles with. Horn. Go to the other side. Horn. The horns mean you don't have enough flux. And when you're a big blob now because of it. Yeah, another big blob, which is no good. We'll keep this one for an example. Anyone joining in? Alright, but just, does it work? Yeah. Does it look good? No. So we don't want these blobs. That's why when you're prepping your surface area, so let's go off of one of, whoop. Let's go over here. All right. A little bit of flux onto where you're going to solder. The tiniest amount of extra solder onto the tip, and you got more than enough right there. That's more than enough solder what you're going to do for at least this kind of work. All right. Now you can see your pads are very shiny. No oxidation. See how these are matted versus these shiny ones? That's enough solder that you're going to need. So you can grab your capacitor, whatever you're going to solder to. Bring it on over. You know, line that up. Oops, I didn't let it flash off. Yeah. After you're done that, once it's all soldered on the spot, just gonna put a little bit of flux and just a touch on one side. Go to the other side. And of course, I did that. I can barely see where I'm looking. go. Got a little flux. See if I can do this by looking at the screen, as I am not used to looking at the screen. There we go. And go to the other side. Like that. And clean up your work area. And you got a nice solder joint. Looks professionally done, not over, you know, it's not like these ones here. Not like this one here where it's all balled up. Because you're not using too much extra solder and you prepped your work. Flux. Tiny amount of solder. Go over those pads. Prepare them. Grab your component. In this case, it's the MLC cap, ceramic capacitor. And MLCC is multi-layer ceramic capacitor. That's what it stands for, MLCC. And I'm going to grab my other tweezers. Line that up. Hit the one side. Let it flash off. Not lined up enough. And again, it's okay that it's going to have that little bit of a bump out there, because we will be coming back to that. A little bit of flux. Not that I've seen. Some people are joining by, I just know chatting. There you go. I have it set so you gotta be a subscriber if you want to chat too, so if they want to, it's alright if they don't want to. Yeah, this is what you're looking for, and not the blobs. Too much solder, perfect amount of solder. Same thing with the one up over here. Perfect amount of solder. So, stacked caps. How's it going there? I'm seeing you in a bit. A little bit of an angle, kind of off pads, but still works. As long as you're not shorting anything out. Good. Good. Stacked. Not good. Too much solder. Good. It's okay. It's good. Stacked caps. Decent. Oh, very nice. Let's do another one beside that right here. A little bit of flux. Tiniest amount of solder on your tip. Run over those pads. Get them prepped up. No oxidation. Looks very good. Grab your cap. Hold it into place. Just a light touch. That's all you need. Yeah. Yeah, no, there's a learning curve. That. Then you want just a light amount of flux again. You come back in for the side to clean it up. Like so. And you just gotta clean it up. So it's not too difficult to do once you get a little process going. Remember, you don't want to get flustered. If this is happening, then you just know you're adding too much solder. And again, you can clean that up. I don't know how to go to computer science. Nope, not the same. Not the same. Oh, what do you mean I've been silent the whole time? What do you mean? What do you mean? I think you just don't have any sound. Logos, banners, posts, ads, website. Oh, nice. Yep. I got a lot of people that come into my channel asking me if, oh, you probably get more views if you did this and this and this and this. And it's like, if I could afford it, I would do something like that. I would. Wouldn't mind helping out a small company. I wouldn't mind at all. Line it up. Tack to one side. Clean up your soldering tip. A little bit of flux. And it's that easy. If you're having crashing problems, there could be capacitor issues, resistant issues, just not giving you proper voltage. First client made website, nice. So, blobby, good prep work, little amount of solder, a little bit of flux, goes a long way. And I'll do it again for anyone that's joining. I'll do this one here. A little bit of flux. You clean your soldering tip with your brass scrunchie. Add a little amount of solder to the tip, very little amount. What you gotta do is just run over the pad to add a little bit of solder to it. Also gets rid of any oxidation. You grab your component. Grab your component. Get it in place. Make sure you got that angle where you want it. Right where you want it. Make sure to get good contact, let flash off. That's not where I want it. So I'll move this. Still not where I want it. There we go. Then you go to the other side. You might need to add solder to your tip. What you can do is just test it by going in with the solder. Make sure you got your in the angle you want. hold it to the spot. OBS was just like, I'm out of here. And then what you're going to do is go back in, just touch. All you need to do. Go to the other side. Clean up your tip, go to the other side. And you just gotta touch, like, very little amount. And you can clean up after you're done that any flux around the work area, on the capacitor itself, or whatever you're actually soldering. It could be a resistor roughly around the same size too. So see how nice this looks? Not bubbly like this one here. It's in good line, it's on the pads nicely. Good joints, good solder joints, which I can show here. Very good solder joints onto it. So here you go. There's the one side, very nice. Not too much, not too little. Same thing with this side here. Not too much, not too little. Now I should probably start removing some of these because I don't need them. And to remove, you can just hold to the one side. Eventually the heat will soak into the whole thing. Or you can just go in, grab some of that solder, clean up your tip, go back in, clean up some of that solder. And this is a way you can do it without using hot air, instead of using hot air, okay? Same thing with this side here. Just hold, there you go. And we got the piece. You got the cap there. And what you could do after that, to have it ready roughly for the next time you're gonna put a component on. So you remove one and you're replacing it. A little bit of flux, run it over, get that pad ready. You can do another one here. Let's do this one right here. So what you gotta do is just wick away, clean up your tip. Wick away, clean up your tip. Go to the other side. As you can see, there's like very little amount of solder there. Hold on to your component. Hold your solder iron to it. And we might need to just wick away and go back to the other side, because we don't want to hold the solder iron too long to it. We don't want to overheat this component. So we'll just keep wicking away as much solder, make this solder joint as little as small amount as possible, basically. So that way when we go in the other side, when it heats up just enough to let this solder go. I guess we'll go back to the other side. There you go. Again, same thing, since you already got it ready. Go in with a little bit of flux. Flat tip works really good. Just run over that pad, clean it up. And you can clean up your surface. Now your stacked caps here, like this one here, it's fairly easy to do them. Clean solder tip. You gotta hold in the center of the cap. Press onto the cap and it should let go fairly quickly. If not, just hold it to it for just a little bit, not too long though. And this will let go because the solder joint should not be too strong onto it. It's just when you're soldering these on top, you're just making sure the contact points are soldered together. You're not, as long as you don't add like it's not blobby. If it's all blobby, it will take a lot longer to get rid of that top cap. So same thing with the one over here, right? If it's really blobby, it will take longer. So you grab the center of this cap. And yeah, put the heat to it, right to it. And it will let go. Alright. These ones here. Hold to it, and it should let go. This one here is going to need a bit more, so I'm going to keep wicking away that solder there. Go to the other side. I was going there a little. We're going to go to the other side of this one here. And let go because we shortened that, made less solder on this one side. Also heated it up at the same time, so when you, again, I'm kind of ambidextrous, so I just switched to different hands. That's why the solder ends this way, and then the solder will be on this way, because I just switch hands. Then when you're done with that, you get a little bit of flux. Clean up this pad now, like so. The same thing with the other ones that you did. Clean up those pads right away. That way they're ready to go for the next time. And once you're done that, you grab your Q-tip, clean up your area. Get rid of any flux. Old flux is no good to work with. Becomes very sticky too, and becomes more of a pain to clean off in the future. So like that. So again, what you're not looking for is the blobs. No blobs. Blobs are no good. You want to make sure you're sitting down flush. Try to make sure you're on the contact points. See how this one's over a bit of a distance? It's over on this one pad more than this one. As long as you're making contact and not shorten out, as in taking this side and making it in the center of this to make contact with this, because it could short out this cap. So having it as perfectly in as possible, as in like this one, perfectly centered, is what you're looking for. These ones, of course, are just fine. But you don't want the blobs. Blobs are no good. Too much solder. I should show some without any flux too, because they can be bubbly. You don't want bubbly. Bubbly is no good. probably can be more prone to cracking later on, and that's no good. So anyway, I got a prep surface here. Alright, so this up right here for you. Go. So we got prep surface here already. So no flux, no nothing on this one. We're gonna go in like so. Line it up. Heat. So it's lined up. And it is making good contact. Everything's flat, everything looks good on it. But we'll might see afterwards, especially if you're using no flux too. What you can also see here with this one, maybe on this side more. Yeah. As you can't really see it, there's horns. So let's flip it this way. There you go. You can see the horns. Right? See the horns. It's because you don't have flux on it. Solder becomes sticky and it will stick to the tip. So all you have to do, if that does happen, it's a little bit of flux. Clean your tip of your soldering iron, nice and shiny, and just light touch. Go to the other side. Again, just a light touch. We'll get rid of those horns. It'll flow the solder nicely into any existing holes that might have been there from not using flux. And again, when you're done, clean up your area. And you got a nice joint. Good solid joint. Good solid joint. Not too much solder too, which is good. So you're not bubbled up like this one. Domey, you don't want it domey. No tie domey in this house. Yeah, nice joint. try to change the angle a little bit too on this. Stand a bit. There you go. All right, so now we got a nice little angle, dangle going on there. That way I can show you a bit more here. Hopefully get a good angle with the light. Yeah, okay, good. So you can see nice shiny soldering tip is what you're looking for. And we can clean up this area here. I'm gonna do one fairly close to the camera there. And clean up these pads. Like that. And you can see just how shiny those are. Right? That's what you're looking for. Grab our cap. You know, line that up. That. I'm going to do the other side. Now, a little bit of flux. I'm going to go back to the other side, clean it up. Clean up the tip. Get a little bit more flux, and you're just barely going to touch this, all right? Like barely just touching the solder, like that. A little bit more flux for the other side. Same thing. Just barely going to go in there, touch the side. Like so. It's not too difficult. So you're not getting the big blobs. Things nice and clean looking. There's no short, as you can see. You can test with the multimeter if you have a multimeter, and you should. If you're doing electronics, you should have a multimeter. Just in case. So when you start doing the smaller stuff like this little guy right here, right? Like this little guy right there. You could short out somehow. It happens. Even professionals still do it. That's why multimeter testing shorts before you turn anything on is very helpful. Hopefully you can hear me all right too. I don't have the mic in the best spot for this either. I don't have a headset mic. Actually, I could set up my headset mic actually. I don't know why I wasn't thinking that. Prep work is key. Now, let's say you are like what I'm doing here. So let's say you are cleaning up and you got some spots there that are grabbing some of the cotton off your swab. What you can do, clean up your tip again, add a little bit of flux to that area. And get rid of it. If it's not enough, go back in with a little bit of flux. Because if you don't add the flux, I'll show you. So if you don't add flux, let's go over to one of these spots over here where I don't have any. Right here. If you don't have flux and you start wiping this, and maybe there's a little bit of flux there. There is still a little bit. I got an idea. A little bit of solder to the tip. And you start going in. Yeah, apparently these spots have lots of, there you go. See how we start doing that? Start getting solder all over the place. That's why a little bit of flux can go a long way. And you just, as you can see, we grab some of the solder back onto the tip. Also makes that area nice, ready for soldering too. Now, let's do another, like, some sort of icy, something that has some logic over here on the board. Go there. Something with some logic. Logic is it's a semiconductor that has some logic built into it to make sure there's certain voltages going where it should be going, and that's Grab it right there. This is a UP controller. 14 leg, I believe. It's a UP616 1S14. Alright, so right here. And hopefully we can see it so you can read it. Let's see. Yep, there you go. UP616 S14. We'll add one of these on. So first thing that we're going to want to do clean up that there. So first thing that we're going to want to do is prep up the pads. So all you need to do, just add a little bit of flux again. Clean up your soldering tip with your brass. And grab a little bit of solder onto the tip. Alright, a little bit of solder. We're going to run these over the pads. Sideways. Alright, sideways. Nice slow little run. And as you can see, they're nice and shiny, ready for their component. The component you match up with either an arrow or silk screening, and as you see here, there's a little indent. Sometimes there's a silk screening or an etching of sort to show the direction. Alright. Now on the board itself, right here, it's actually a silk screening indicator where to put that component. So it goes like this. Alright. Match that with the silk screening. Then we line these up. Like so. We can tack this end, tack that end. Tack that one a bit better. Now that's tacked. Go over to the other side and do the same thing. We're going to tack this one and this one. Okay. Next, what you're going to want to do is add some, well, clean up your tip first. You're going to add some solder to your tip, like so. And then you can add some flux to that side and to that side. And then the same thing that we did for cleaning up the pads, we're going to run our solder iron slowly across each of those. And you see how that put a nice little dab onto each one of those. You gotta go to the other side now and do the same thing. Slowly run it across each of those. Yeah, yeah, solder that tip. And that's it. That's all you gotta do. Now let's say, so what I'll do here is get rid of the flux. I'll get rid of it all the best I can. Hopefully I can show this. I showed this before, but just in case anybody's just joining in, right? Now let's say you go and you're doing it, and you got, oh my god, that sounds amazing there, SD. You gotta, let's say you mess up and you got, oh god, you got You got a big glob of solder somewhere, right? Don't freak out. It can happen. It can happen to the best of us. Maybe you just forgot, you're in a rush, and you didn't add any flux at all. Clean up your tip. You're going to add a generous amount, a little bit. You still don't need a lot, just a generous amount of flux to that. And you're slowly going to run your tip across each of those pins again. Now, you can see there, in the one spot, there's still a little bit of solder. So you're going to go back on with a little bit more flux. Again, slowly run solder iron over it all. And it'll clean all that up for you. Nice. Hopefully Iceland's doing all right. And that's how you can clean up if you make a mess. Again, always when you're done, clean up your area from the flux, all right? Clean it up really good. Old flux is no good. Doesn't matter what kind of flux you got the best stuff in the world. Old flux is no good. All right? Not too bad though. Not too difficult to do. That's how you do something with like multiple pin logic board of some sort. Kind of like, you can do this one now if you want. We can do an 8-pin. I've already shown how to do an 8-pin earlier, but I can do another 8-pin here and show you. Why does the chip look like it's slightly jello-ish? Are you AI generated? No. What do you mean jello-ish? What do you mean jello-ish? Oh, it's probably because the flux I had on it. Oh, I didn't even notice too, as you can see right there. Look at that. That's one thing you gotta worry about. These little solder balls sometimes can be a bit of a pain. I didn't even see that. Where'd he go? There it is. Yeah, definitely a reflection from the flux. Are you AI generated? SD. Let's just clean up that. I didn't get all the flux from last time. There you go. I need to get better. These are cheap cotton tips. They're not the greatest, but they do the work. They do the work. So let's do an 8-pin logic board. All right. So that's one of. Where's my? Do I not have another 8-pin logic board here? Oh, I got another 14. I got a 14. I got 10. Oh yeah, I do. Right there. There it is. And here's a logic board. All right. So here's a logic board. And when you're looking at them, let me just clean it up a bit. Now let's say you can't read anything here, right? All right, you can't read anything. You can't even see the direction. Let's just say you can't see that little. Let's say you can't see this little indicator down there. You just can't see it. What you might need is a little bit of thermal paste. All right, not too difficult, not too difficult. All you gotta do is grab a little bit of thermal paste here. And you gotta put a little bit on a Q-tip. Not much. Just need a little dab, little dabby dab. Thermal paste. You gotta hold whatever it is you work on. Don't matter. Doesn't not matter what it is. Doesn't have to be one of these little logic boards. You're going to hold this logic board. Like so. Right? And you're going to rub that over the whole thing. Right? Like that. Cover it up. Boom. Then what you're going to do is clean it up with the other side of the Q-tip. You clean up really well. Right? Clean it up really well. Then it'll be left with that. Alright? Now you can read everything. You can read what it is. PM25L V512. And you can see the indicator, which way it goes. A lot easier. And it doesn't take much thermal paste either. We gotta clean up this area. Really good that has some of the thermal paste though. Because thermal paste and solder does not go together. Yeah, that's all you gotta do for it. If you are having trouble reading something on what are you talking about? My mic's all connected, everything's fine. What? You can hear me just fine, right? Anybody else there? Should be able to hear me. It shows my mic's working. Yeah, exactly. Yeah, go. What? Yeah. Okay, I was gonna say. Yeah, Squeeze, it's just you. It's just you, Squeeze. Told you this. I told you this like an hour ago. You probably don't have sound on or something. Okay, but that's what you're gonna do if you can't read a component. Just add a little bit of thermal paste and then wipe it away. You'll be left with that. And you can clean it up even more. And I'll show you that once I get this solder into place. Now, what you're looking for indicator is this little either dots, silk screening, etching, or an indent. This is an indent on this one. And on this board here, you'll have a little silk screening on the board. This is a solder spot. This is solder. This is a silk screening. So you're going to match that with that. So I gotta flip it. Flip it. Alright. So match this dot with this corner, because that's way the silk screening is shown. That's an indicator of which way the controller needs to be put. Now what we gotta do. But I hear many voices. What do you mean you hear many voices? Nah, it should just be me. Unless that's just you. A little schizophrenic, are we? So we're gonna add a little bit of flux. Gonna add a little bit of solder to the tip. Not much, but just a little bit to the tip. And we're gonna run sideways over the contact points. Alright? So we add a little bit there too. Let's just do a circle on that. There we go. Make that look pretty. And that's prepped up now, and more than enough solder that you're gonna really need for making contact. This one here, yeah, put this, line it up. I have to grab my other tweezers because those ones don't work for me for what I'm doing here. sure we line that up good. Like so. Alright, make sure it's lined up good. I try to use the screen instead of looking at it. I get better at using the screen. Try to get better at it. Every time I look at the screen, I move. You attack one side. Make sure it's all lined up good. So you might need to slightly move that. Attack the other side. Move on to the other side. Yeah, squeeze must have muted something. Attack this. Attack that. Alright. Make sure they're good and tacked. Then we're going to add a little bit of flux to both sides. Add a little bit of solder to the tip. Not much, just a little bit. And we're going to run diagonally like we did for cleaning up the pads, but over that. And the same thing with the other side. And to clean it up more, we're going to clean up your tip. All right, clean up the tip of any solder. A little bit on it is going to be just fine though. Yeah, a little bit more flux both sides. And just run it slowly across like that. Cleans that up very nicely. Same thing with the other side. Nice slow run over it. Cleans them up nicely. Alright. That's how you're going to add components. And what we're going to want to do is clean that up now with a Q-tip. As you see, this yellowish color is all flux. On top of that, it's also flux. So clean it all up good. There you go. I'll turn this in a way so that way you can see it a bit better. A little bit off is not the worst. So that's our 14 pin, 8 pin, another 8 pin. I'm not used to looking at the screen. I'm used to doing everything and looking at the actual board, and I'm not used to looking at the screen. I'm trying to figure out everything that I've soldered today. So there you go. Transistor. Another logic board. Could be BIOS. I'm not sure what it is. I have to search up what these ones are. Another 8 pin. 14 pin. Which is another logic board. And then we did have a tantalum polymer capacitor soldered there, but I took it off. And then we did all of these as well. And a bunch of them are just for showcasing. A bunch of these are just for showcasing. So I'll show you. Put that on there. So a lot of people end up with this, which is a big, this is just too much solder. And you can clean it up, but you don't want to solder something on and have to clean it up every single time. It just takes too much. The card is just a broken GTX 260 V2 that has an internal short somewhere on the card. It's somewhere internal, or the core is done for, and it's worthless. It's worthless. So I took all the components off this board. I took all the components off of this board yesterday, or was that the day before? One of those days. So I'll show you. Everything's off of this board. I'm using it to show how to solder, and also just using it as like a decorative style piece. Everything's off this board, all the chips. Saved all the GDDR3 chips. So they're actually really good, GDDR3. So I saved them, and I got them in a baggie. And I got everything's desoldered except for the chipset, and then the driver chipset for the display. That's a display. So that goes to your like DVI. On this one here, it's dual DVI 1PS. Yeah, that's just for a display control board. There's the chipset. Yeah, that's what I did the other day. Here, there we go. So it's just a learning board to show people how to solder. And then I got a bunch of, like I said, different. This is how you want it to look. And you can do this basically every single time if you do it a certain way. Prep work is the main thing. Prep work is the main thing to achieve this. Not to get this. Same thing with up here. Perfect, right? That's what you want to look for. And you can do that every single time. And then also showed how to do these smaller ones here. Like an 0402 or smaller. Something that's this, like a size of a grain of sand, basically. Very, very small. So right now today I'm just more or less trying to show my bad. How to do soldering with soldering iron and not with a soldering like hot air. Hot air is going to help you do like these kind of logic boards, which is like your PWM board, which is going to be some sort of resistor, capacitor, filtering capacitors to go to these pins that goes into a logic board to go out to an out somewhere. You generally have two sides in, two sides out on these. So there'll be like a resistor divider and just resistors going over here, and then filtering capacitors like 1 microfarad or 0.1 microfarad 0402s or capacitors that go into it to a logic board, which is I do a lot of modifications on graphics cards, so I do quite a bit of soldering. I go for records on graphics cards and that, so I got a few good records. So here is the logic board or PWM board for that right here. But you can't really do this without hot air, unfortunately. Here it is. And this is a NCP. Flip that around for you. Oh, no, that's right. This is not, that's GTX 460 NCP 538. This is an ADP. And the ADP is like manufacturer, and then it'll have the actual code of what the actual component is. Okay, this is an ADP logic board. And that goes here. But you can't hand solder this, unfortunately. Be nice if you were able to, but you can't, because you need to be able to have this big ground spot. And then basically information goes into one of these. More or less different voltages for throughout the board. Memory voltages, core voltages, whether or not you got proper 3 volt, 5 volt, and then it'll send out a signal, it'll go into this, there's logic into it, go into the other side. Yep. There you go. And then this right here is just a big ground pad. But inside this chip has logic to semiconductor, has its own information into it. Yeah, no problem. And yeah, so information goes into one of these pins. Could be ILIM, could be a feedback pin, could be voltage sense pins, could be VID. VID is a lot. So VID is just like your power tables for voltages and power table for the card and how it's set up. Now we put into the BIOS chip as well, which is another logic that I've shown here, which could be one of these here. Either this one or this one. Your BIOS is usually an 8-pin, generally an 8-pin of some sort that has logic. Usually has like an enable pin, has voltage in as well to give power. The enable pin has to have a certain voltage to it to even turn on the BIOS chip. And if you don't have a proper voltage going in, or if you have too much voltage, the BIOS chip won't turn on and give power to the rest of the board, because that's part of its logic. Yeah, that's it right there. And then we also got like switching frequency logic boards, which are very, very small. Just give me a second here, I can find it. Like I said, I saved everything I wanted to save for future builds. Right here is the logic board though. Right here. So here's the logic board. There's the pins. There's the your plane, ground generally. So this right here, switching frequency. And what this does is it'll go here. It'll go here on the board. There'll be a resistor and a bunch of capacitors that go with this as well, to make sure there's certain voltages and steady voltages that go to this. And what that does, it's switching frequency. So switching frequency is for this. Over here, it'll talk to, I'm trying to make sure I don't push those off the edge. It'll go to here. Try to show that a bit better. And this is your MOSFET. Alright, so there's your 2-pin MOSFET there. And that right there, that switching frequency controller on the other side of the board. And this also your PWM. Some PWM not really, but most time, generally 99% of the time mostly, the switching frequency will be part of the logic board for PWM, and then you'll also have your switching frequency for the actual for your VRM per phase. And then there'll be one of these per phase. So one of these per MOSFET, per choke. So like per choke, which will get put up there. So we'll have one MOS. So this board here has one high side, two low side. All right. So we have one high side, two low side on this board. That's how this one was made up. And it was a 4-phase card. Then we got our choke, our inductor. Steady voltage out of that. Goes through a couple of capacitors. And then goes through the board to the core. And yeah, it's not too difficult, but it's not easy to figure out sometimes. And then this card was pretty modified too. Give me a second here. This. About this board here. This is what I generally do. Modifications to graphics cards. Extra caps. Extra can caps. Aluminum polymer. Extra tantalum. Surface mount. Extra capacitors on core. Memory chips as well. And then we got voltage regulation, so I can change the voltage for memory and for core. This card also has no overcurrent protection and over voltage protection onto it, so basically you can blow up this card very easily if you wanted. And also has switching frequency as well done on it. So here's the PWM board right here. So right here, if you can see that right there, actually I can zoom in, you can probably see a bit better. So right here is a piece of wire that's been tinned up, the contacting two points for this board here to put them together to get rid of voltage, like overcurrent protection. And then this needs to be fixed up because I was trying to do some testing, but I need to fix that up there, make it look better. But this is redone resistor divider for the switching frequency. So the switching frequency was 270 kilohertz, and now it's 920 kilohertz due to the fact I changed the resistor divider. Not recommended by any means. But yeah, this one it's fully done up for mods. It's GTX 460, and I also have videos out there showing it. But that's generally what I do. I modify graphics cards and that. So. That's what I do. So again, what we're looking for is as clean of a job as we can, especially if, let's say, you're adding on to a spot on the board where it does not have a capacitor and somewhere onto a capacitor, and you add on, and then when you're doing modifications to it, you're going to stack up another capacitor, MLCC capacitor, so MLCC, multi-layer ceramic capacitor. You got to stack another one on top of this one. You're not going to go past stacking it. It causes issues and not as good as just double stacking it. Just one on top of this would be more than enough. That way you're not making any kind of like impedance or issues with the resistance onto it. But yeah, there you go. That's what you want it to look like. And when you stack it, it's easier to mount it on there, blah, blah, blah. A lot of people are having issues and they do this right here, bubble. Yeah, bubbles. That's just too much solder. Once you start getting the technique down, you should be able to do this basically every single time. Now, sometimes you're not going to be able to do it every single time, but once you have it set up and you make yourself comfortable to do an area, so let's say this one, and this one, you'll get a lot more better at it. Once you start doing the smaller like 0402s, 0102s, 0201s, these smaller ones are a bit trickier, but you can still do it. That's like right here. These little guys. So if you want to see me solder any specific part on a board, just let me know. I don't have anything set up to do memory chips right now. I need to get BGAs for one. I need to get solder balls for one. I do need to do that. But I can do that if you want. Where did I put those memory chips? So I took all of these off the last stream. I took all of them off the last stream. Checked them over. There's still a little bit of flux, so there's going to be a little bit of color, but yeah, clean these up a bit more, but they're ready to go for wicking away the rest of the solder and then getting prepped up for adding new balls on. I took all these GDDR3 chips off because these are actually really good GDDR3. They overclock very well, very well, with actually not a crazy amount of voltage. I got all these ready. And they came off quite nicely. A couple of them took a lot of heat, but that's because of location, probably a lot of copper on the board. Some PCBs can be wild. Once you're down a few, you start understanding. I don't care about your stupid game. Yeah, so that game's fake. Doesn't even know that you can't run that kind of frequency even on chilled water. You need to use, I mean, rare 1300Ks will do 6.8 or 6.9 gigahertz on dry ice, but you need to go colder to do 7 gigahertz and higher up. Like you can't, on water is impossible to get to that frequency. You might be able to do 6.5, 6.6 on water, on chilled water, but that's it. Even with a silicon lottery chip, you can't do it. That's why I don't like those stupid games that you play. They're not true at all. Yeah, but they can at least give proper overclocking, because you can't. I mean, they should. I mean, I guess maybe they just don't know. They don't know. I mean, if you don't know, you shouldn't be putting it into a game, in my opinion. Oh, okay, yeah, makes sense. Dumbass making games, basically. Yeah, no problem. And if you want me to do anything specific or any other kind of techniques you would like to know about, can help out. You know, quite a bit of soldering, man. Am I the best of the best? No, by no means. Yeah, I think could be. I understand how people, but yeah, the OC are definitely not real. I just know, I know, I know all too much about what hardware. It doesn't matter if it's AMD, Nvidia, or Intel, whether it's CPU or GPU or even motherboards or RAM. I just know how far you can OC it on what, with what voltages generally. And 7.15, it would be that'd be awesome. I would love it. I would love a 13900K that could do that on that water. That'd be awesome to see. We're almost at 1,400 subscribers. Alright, let's do another here. Let's do this top one there. Again, a little bit of flux goes a long way. Clean soldering tip. Add a little bit of solder onto the tip. Not much, just a little bit. Run it over that pad. Alright. Like so. Yeah, 300, more like 1500. It'd be like 1500 or something like that on this board. It's around that. It's an insane amount. Yeah. No thanks. I mean, you saw how long it took me to take off. What, a couple hundred? Just to take them off. Again, it's okay if you get this little bit of a horn. It's fine. Just leave it as is. I hope the card. I hope the card work after. You guys, stop talking like that. No. Alright, again, it's okay if you got this horn. Because what we're going to do is clean the soldering tip up. Clean it up real good. You're going to add a little bit of flux. Not much. You're just going to touch the solder. As I touch the solder, it will go like that. Again, clean up the tip really good. Clean up your tip again, just to make sure. There you go, like that. Same thing with the other side. We're going to go to the other side. We're just going to barely touch it. Like that. And we can clean this up. Yeah, they don't hand solder in factories though. They use a low melt PB free solder, and that is it's a flux, so it's a flux, and it's solder, put low melt solder all in one, and they put it over the pads and all that, and then they put the components with a pick in place onto that. It's different. And that's hot air. They're using hot air. Yeah, why I want to turn on. Alright. It's completely different. I'm trying to show what you can do with a soldering iron. You can do a lot of different jobs with just a soldering iron. Alright. So what I'm going to do is clean this one up. How it's done? You mean how it's made? How it's made. Is that show even still running? So I do that. Then we're going to grab a little bit of flux again. I mean, very little amount of flux for it. Clean up the one side quickly. that. We're going to go to the other side and do the same. So let's go to the other side. Voila. It's that easy. Ta-da. Ta-da. So again, to anyone that's just joining, if you're having like, this is how your solder turns out when you're doing this small soldering, just ask me in the comments there and I'll show you how to solder like this. And just show you a little technique that you can teach yourself. Do a few over and over and you can teach yourself how to do it just like this every single time. No, no, Pep, not 374 more to go. Oh, no, that's not gonna happen, man. All right. So if anyone's there new, just if you don't want to subscribe to message in the chat, you can just, or if you don't like the techniques, like my little tips and tricks. If you don't like my tip, it's okay. I get it. But a lot of people end up with this. Even people that do quite a bit of soldering, because they just haven't learned how to do it a certain way. And it's okay. It takes time to learn how to solder. Especially micro soldering. Micro soldering is a bit of a technique and you really gotta learn. So we just did that one right here. And just got a bunch to showcase on whether or not what's good and not. If it's just a little bit like this one here and it's just on a little bit of an angle, it's not a big deal. Not a big deal. It is nicer to have them, looking really good on the pads. Nice solder, not bubbled up. Everything looks very nice though. And there is a way to do that basically every single time. Once in a while you might have you're rushing a job or something like that. But you can basically do that every single time. If you want to see any kind of like logic boards done too, I can do that as well. I can do some more of those, like some 14 pin or 8 pin as well. I've already shown how to do that. You want to see how a like tantalum polymer capacitor is done, you can do that as well. Hopefully I got the stream looking fairly decent though for you. It's like camera's on a decent angle for you, so that way you can actually see the solder joints on them. And yeah, you can look at the bubbled one, how much solder there is on it. You want to see how these smaller ones are done as well? Like an 0402 or smaller, let me know. I can do those as well. Anything that you can do by hand. And you can do a lot by hand. A lot. Just like your PWM board, though, something that's going to need heat in the center underneath, like a logic board of some sort, like this, you will not be able to do by soldering by hand. You just won't be able to do it. Unfortunately, it'd be awesome if you could, but you just can't. You need to be able to get heat to this big ground plane. Just give me a minute and I'll be right back. Shaking the desk. Oops. Oh, my coffee. Oh my god, I forgot all about my coffee, guys. Oh my god. You poor, poor thing. Neglect. Neglect. Nugget, are you hungry? Want some food? Oh, somebody getting some sleepy sleeps. You hungry? Yeah? Yeah. 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 Here you go. Can you wait? Can you sit? Sit. Wait. Sit. No. No. Sit. Sit. Hi, hi, baby. Hi. Sit. Ah, sit. Good girl. You shut up, princess. Good girl. Good girl. It's all yours. Yep. She's such a smart kitty. Alright, give me a minute here. Again, if anybody wants to see any kind of soldering or just wants to see some techniques for soldering, let me know. All right. All right, what should we do? Let's remove. Let's remove the logic board here. So I'm just going to run over the logic board with the soldering iron. Clean up as much of the solder as I can on the one side. I'm going to grab tweezers. I was able to do the whole thing. Nice. Because I got enough heat on it. What I'm going to do is clean that up. Get it ready for another solder job here. So a little bit of flux. Yeah, clean up the tip, add a little bit of solder to it. Like this. You gotta run sideways. Clean up the tip again. You can solder that back on. So here's the board. Little bit of flux. Now, again, we got this little indicator for direction, and on here we got silk screening for indication. I'll line those up. Line up the board to the pins. Like so. Tack one pin, tack another pin. Go to the other side and do the same. Tack one pin, tack the other, like that. Yeah, make sure we got a little bit of more flux on both sides. Clean up the soldering tip. We're going to add a little bit of solder to it, like that. With the tweezers, we're going to hold down on one side of this logic board. And you got to run the soldering iron the same way you did for prepping it. Like that. Alright, same thing with the other side. Hold it down. Like that. You just clean up the flux. Got a little bump on that. I'm just going to clean that up. That's just a grounding spot where a screw goes in. That's all that is. That's how you do a logic board. Fairly easy to do. Again, to take it off, clean up your soldering tip. We're just going to drag it across, clean up the soldering tip, drag it across. Same thing, keep doing it. So you get lots of that solder off of it. Well, as much as possible. Clean up the other side. Gently lift up on this one side as we are heating up these pins here. I have to keep cleaning the tip. If it's not going right away, that's okay. What you can do is add some flux to it. Then we can go to the other side. Clean up the tip. And go to the other side just to make sure they pull this off. A bigger tip would be nicer too, but sometimes you don't need it. Alright, so that's, oh, my bad. So this is lifted up a bit now. Clean up your tip again. It's lifted up a bit now though. So just hit it a couple more times. Now that's lifted up a very little amount. You're not trying to yank it off. You're not trying to pull hard. You're not supposed to pull extremely hard. Just enough to get some movement going. So that way the solder on this side, since you're going back and forth, you're heating up this side more. So that way you can lift up this side. Now that side's up that little amount. You're not going to try to yank. You go back to the other side now. You do the same thing. Just run it across these pins slowly. Back and forth. Now that's lifted up a bit. I don't know if you can see that at all. Lift it up. Go back to the other side, and we should be able to lift this side up all the way now. This one here. Should be able to lift it up all the way. Ta-da. Alright? You're not trying to yank it. If you yank too hard, you can rip traces. You can rip these pads right out, which is no good. Now since there's already some flux here, I'm going to run this across these pads to prep them up. And we can clean it up. You see how we have this right here? Like a little spot there. It's got a little bit of flux to it, not much. Clean up your soldering tip. You gotta make sure it's really clean. And you gotta run it over these pads slowly. And voila, it gets rid of it. And clean that up again. That's good for another test. If anyone wants to see another test. Not too difficult, okay? It's not that bad. And we got another logic board here that has more pads if we wanted to do that one. I think we'll do a transistor or a diode now. So we got diode here, 3-pin diode. or a transistor of some sort. This is a voltage regulator. That's what it is. So 5 volt can go in and 3.3 volt can go out. Or it could just be a 3.3 volt in and 3.3 volts out. Alright, so you have one side here, right here. This is out. This is voltage in. It's not showing that good, my bad. So here you'll have voltage out, voltage in, and a ground. Now we'll go there. So what you can do, like always, you're gonna add a little bit of flux, clean your tip, a little amount of solder to the tip, a very little amount onto it, and you gotta run that over those pads. Prep those up. Alright. I use 8341 no clean flux. You can get it fairly cheap. That's why I like it. And it's really good for electronics. So now you're going to want to line these up. Tag it. To the other side. Tag those pins on. Now, let's say somehow you've connected these points together, which I'll show here. How to, by adding too much solder. Say somehow you've contacted or shorted these sides, like that. Oop, and completely took that off. There we go. Say somehow you managed to do that. I gotta take this one side again. Right? Somehow you've managed to do that. Okay? I don't know how it'll happen. All right. If you're just learning, that can happen. That can very well happen. All right. Now, you don't want to freak out. All right. You don't want to freak out and say you've ruined it, because you didn't. You didn't ruin nothing. It happens. Just gotta add some flux to it. And you're gonna hold this down, and you're gonna drag this across. Alright? Alright? See? You didn't ruin nothing. You didn't ruin nothing. It's contacted, it's on there, it's not going anywhere. There you go. Alright? So it's one thing people need to know when doing the soldering, is not to freak out and thinking you've ruined something because you've added too much solder. You can always remove it. Flux is your friend. You don't need a lot of it either. Alright? Now, as you can see, it's a little off. It's off, but the contact points are good. So you can do that, and that right there would technically work. There's nothing wrong with that. There's actually nothing wrong with it. It's still perfectly usable. And sometimes you can get some boards too where it's on an angle because somehow when it's soldered, it didn't fully flow into place, even from factory. Yeah, they're just using way too much flux. You don't need a lot. Yeah, you don't need that much. Yeah, I know. I've seen them, man. I've seen the videos. A lot of people think you need a lot. You don't. So let's go to, let's see. What is a fairly difficult one to solder? Well, let's just do this way. Maybe show it. No, still not in the right spot. That's fine. I'll do it this way then. All right, so let's do. Let's do one of these. There we go. So here is a MOSFET. All right. And a MOSFET is one that goes there. There you go. All right. So MOSFET goes there. Now, a lot of people would think you need hot air or something to do it. You don't. So underneath, it's a 2-pin. Oh, my bad, I'm not showing it. It's a 2-pin. It's one of the pins got cut off. Generally is a 3-pin, but it's a 2-pin. And you generally need hot air for this. You don't. I'll show you what I mean by that. So what we're going to do here is prep this up first. All right, we're going to prep this up first. How we're going to do that? A little bit of flux, not much. Clean solder tip. And run this over the whole pad. Like that. All right. And then I'm going to get a little bit more on flux onto that and clean it up just a little bit better. Like that. And same thing with our spot that we're going to solder to, and which will be this one right there. All right, this one right here. So a little bit of flux on there and those 2 points, like that. Take a soldering iron, we're going to roll it on there. Like that. And our 2 points prepped up. All right. Then what we can do is flip this around. And this, put it into place. So our contact points are good. We're going to tack it. We're going to tack it. All right. So that's on there. That's on there. It's tacked. The hard part is tacking this side. This connects to this pad underneath. And you got to do a good job of contacting this. So what you have to do, add some flux to it, not much. You add a generous amount of solder, okay? A generous amount. And we're going to contact this, hold, and pull. Alright. Now you might end up with like a little horn or something onto it. A little bit of flux, not a big deal. Clean up your soldering tip. And roll it back the other way. Alright. Then we can pull it back the other way again. And you want to make sure that's good like that. You want to make sure there is a good amount of solder on that. And we can clean it up. That's good, like that. You got solid, you got good contact, good ground, good contact. And you got your gate, so one of these sides will be your gate, one will be source. But gate is the one for your power. Now let's say you don't like how this is contact and you want more contact. It's fairly easy. Just clean up your solder tip again, add a little bit of solder to it, dab it on, contact, dab it on, contact, little bit of flux, contact, contact. And that way you got lots. Good contact for it, alright? It's not that bad. And that will work. That will work without any hot air, without doing that whole surface and whatnot. Even though that's how they're done from factories, this whole thing is done by air. This whole pad is contact underneath. As long as you have a generous amount onto this and a generous amount of actual solder, to your tip, it will flow underneath a bit too. That's the thing. That's why you're going to add a decent amount of flux. You don't need a whole lot though. And let's see if I can show how it will flow a bit. Again, a generous amount of solder. Hold that to it. Not bad. So not much actually went underneath it. Probably because it's already filled up enough. And we'll just run it to again. Clean it up. A little bit more flux. Like so. There we go. Like that. That's good. It's good contact. Bunch of solder probably to flow underneath a bit. More contact underneath that as well. And good contacts for that. My solder won't stick to the tip. It just balls up on the wick or falls off on the floor. Your tip is worn out. You need a new tip, or you need to tip tinner. Where's my tip tinner? One sec here. You might need some tip tinner. Some tip tinner can help revitalize your tip as long as it's not too far gone. Now, to remove this, we're going to have to hold this, get rid of some solder, so you're going to have to do it a bunch of times to remove some of the solder. Keep cleaning your tip as you go. Every time you make contact with this. Like that. Then because there's a lot of solder on this one side. You gotta hold this side and you're try to lift at the same time as you're heating up this ball of solder. If you can't, that's okay. You might have to go back to the other side and take off more solder. Again, isn't a big deal. You can add a little bit of flux to it as well. Not much, a little bit. And it should pull off a bit for you. Just make sure you continuously clean your tip. And if you can do this quickly to each side, clean it up, and then go back to the other side within a quick amount of time. The solder's still semi-soft. So hopefully you can lift this. I'm gonna hit this side again. So I lifted a tiny amount, not much. That's because we still have too much solder on these contact points there. And I don't believe I'll be able to lift this side up. Just due to the fact there's so much solder holding this side on. That's why you want to get rid of as much solder as you can off of this. That way it makes it somewhat malleable. So you can lift up the other side. So let's do this. One. That. Right, went up a little bit again. But we still got too much solder on the other side. At least if you're doing it by hand, taking this off with soldering iron, you're not having to worry about overheating the MOSFET too much. This MOSFETs do not like to be overheated. Like you can put on, you literally put it on with hot air, and if you overheated it, it can just not work, or B, within like a week, it just stops working. Now we're going to add some flux. Add flux to both sides of this. That's going to help hold a bit of heat and get rid of some of this solder for us. Nice. It's actually doing pretty good. Hopefully, we can lift this end up now. So I keep slipping. There we go. Keep moving it, my bad. Alright, so we got a lot of that solder off that one side off too though, which is good. And what should I solder? I might take a sub and have two subs. Well, do make a sub. Got a solder wick. This would be a lot easier too. Solder wick can get rid of a lot of the solder, basically all of the solder, most of it. It makes it a lot easier to do this. I just don't have any right now. Oh, keep moving it. I'm trying to show. There we go. Now we're gonna go back to the other side. Maybe. Maybe lift this up finally. Hold that to it. Apparently not. So I'm going to move some heat to it more. More heat. More heat to keep the solder nice and soft. I'm going to try to get rid of a little bit more here, hopefully. Just like barely any holding on to it now. Oh, we got it off. Nice. Yeah, so the one side was off all the way. It wasn't already off all the way, which is good. So I just went back and forth. You know, just kept it cool, kept it hot enough to keep it melted, and there you go. And what we're gonna do is get this ready for whenever we do add another MOSFET. What we're gonna do, clean this up, clean that up, voila, just like a so. Clean this area up. Of any extra flux. So we got a bump there too. There. Good to go. There you go. And just like a saw. Yeah, once you start doing a lot of soldering, you'll know how to not get certain results, get more results onto the better looks. Again, there's nothing wrong technically with this. It does just use too much solder, for one, especially if you're doing a lot of components. You're going to use a lot more solder than you would on something like this. So when you get something like this, you're also making it so that way it's harder for you to solder something that's beside it, because your angle of your tweezers has to be a certain way to bypass it. If not, and we go and try to do soldering on this component, you're not going to be able to hold it proper. So having too much solder can be, it works, but also does not work, especially if you have more soldering to do. If you have more soldering to do, it's not going to be good to have all this solder. And if you're doing a lot of soldering, not too much solder here. Got a little something there. There we go. All right. So, and then also having these big balls here, when you're starting to do soldering on something that's a lot smaller here, like this. Got a piece of a Q-tip there, some cotton. Come here. Come here. Oh, I don't let it go. There you go. You're trying to do something small like this. You're getting that blob before, and you're using basically the same amount of solder. There's an easier chance, or more of a higher chance. Get out of there. Higher chance that you will short this out. If you short this out, it'll short, like the card just won't work, or you could technically destroy a cord depending on what's actual, the chances of it actually causing catastrophic failure is fairly low, but there are still chances that technically can happen if you are doing something this small. So always try your best to make it look really good. Try to learn the technique, the steps. There's always steps for this. All right, there's always steps. So let's do, go. A little bit of flux, okay? A little bit of flux, not much, just a little bit of flux. Clean your solder tip with the brass. A tiny amount of solder to the tip. A tiny amount, as you can see, tiny amount. Run it over those pads. Alright, so you got fresh start, fresh solder. Better solder, sometimes you might have better solder that's actually on the board. Better solder, easier to solder. Again, you gotta clean your tip. You gotta grab your component, your MLCC, your multi-layer ceramic capacitor. You gotta grab it. You set it up into place where you want it. Line it up nicely, like so. Tack it in place. I slipped. Tack it into place nicely. I should probably move that over a bit too. There. Alright. Like so. Now it doesn't have to look perfect right now. It's okay having this little bit of overhang in that. And we're going to go to the other side. Hold it down. Go in with this, the other side here with your soldering iron. Get that ready. Like so. A dab, a little dab. a flux. Clean up your soldering iron. You're just going to lightly touch the side, all right? Lightly touch the side. Yeah. Wow. Now you go to the other side. Do the same. Like so. And then clean up your area. All right? Another Q-tip here. I need a fresh Q-tip. Go. And you can see how nice that turned out. Right? That's how you want it to look every single time. Now this side here, you might think, oh, there's no solder on it. Well, there is. There you go. Because also when you're doing this, you're holding it to it so that way at the bottom, you're flowing some solder underneath and contacting all underneath. And it will flow. Like as soon as you hit the solder with a hot iron and a little bit extra solder, it will flow underneath, make good contact. All right. Shunt mod on the HT 7850. Depends if you got certain. Yeah, I mean you could. Do you have proper resistors though for it to go on the shunts? The shunt mod is just piggybacking with another resistor on top of it. I mean, you could technically just remove that resistor too. The shunt. The shunt is a resistor. A very low ohm resistor. Or high. It depends. It depends on card too. But you're piggybacking generally. If you don't know how to solder proper, I wouldn't recommend it for right off the bat. Because usually on a shunt too, they're larger resistors that take a lot of heat, and yeah, most people don't prep it either. Most people are not prepping it, which is kind of like what I'm showing here with the prepping of the pads. Oh, way here, prepping of the pads, right? So you're gonna grab new solder onto your tip. You're gonna use a little bit of flux onto the area, and then you gotta add the new solder to it like so. That makes it so that way you're using a better temperature solder. For one, you're mixing it into it, making it better, and you're also getting rid of oxidation. And on old graphics cards, the pre-solder that's already there, it's generally a PB free or a lead free solder, and it's usually need more temperature, and with the bigger shunts or bigger resistors, they can be tricky. They can be tricky. Take some time, and people have trouble with them, and that's why I have videos out there showing how I do it. Because you can also go off of like a logic board of some sort, like one of these. So do I have one? No, I don't think I do. Which are generally an ADP board, which is a logic board that senses the voltage and like the actual how much power you're using. It's a power board, but it's like it's a logic board like this, and then there's resistors and capacitors that go to it. The capacitors are for a full-on 12 volt to it, so for one of the pins, and then another pin will generally be for like a 5 volt. It depends on the card too, but it's an ADP logic controller board that senses the actual power before it goes to anywhere else, really. So what you're going to do is piggyback a resistor on top of a capacitor, which is different. It's smaller too. It's a lot smaller, but it's also very easy to do with a soldering iron compared to the bigger resistors or bigger shunts. And I find smaller soldering a lot easier, especially if you have a cheaper soldering iron, or depends on the solder you're using. I do have videos out there showing how to do it. Done it on a lot of cards. And again, I like it done a certain way on the actual power board, power sensing board. And let's see, do I have any? I mean, I have some resistors, but I think they're too large for these caps. I could show how I do it. Just to show. So I do have. Where are they? There they are. Let me grab these caps here. There we go. So we got cap. Alright. So we got the cap. Gonna this way. Actually, do I have a spot? Oh, I do have a spot for right beside. Like, okay, so we can actually show roughly where there. So let's say this right here. Let's say this right here is the ADP controller, some sort of voltage controller. And there's a cap. There's generally 3 caps. Right? There's generally 3 caps. It's 4. And I'll solder this to this quickly. We're going to do this. Clean soldering tip again. Add a little bit of new fresh solder to this pad. Like that. Alright. Yeah, grab your cap here. I need to move the board. just quickly doing this just to show. It's not going to be perfect by any means. Right, so there. So you'll have that cap on there. Now, what I like to use are 2R2s. So think of this as a 2R2 and 2R2s. And these resistors can be many different sizes. And the cap's generally not this large, by the way. The cap, generally not this large. It's generally a 0608. Alright, so think of this as a 2R2, and 2R2s work really good. I'm just showing soldering techniques on a whole bunch of different components. That's all I'm doing. I do whatever soldering you would like to see and show you techniques on how to do it. Now, what I'm doing here is show and squeeze what I like to do for piggyback. Piggybacking on top of a capacitor that goes to a control board that senses how much power you're using, which is generally an ADP control board. All right. Now what I'm going to do is there so we don't move anything around. And again, think of this as like a 2R2. I like to use 2R2s because they will make sure you don't go into a limp mode. Right? So you gotta line this up. Right? You gotta line this up. Might not be the exact same width as the actual chip, but that's okay. And you gotta tack this side. And you gotta go over to this side, do the same. Oop. There we go. So you just gotta put it on top. I'm not gonna make it look pretty because I'm taking this right off. But you gotta tack the 2R2 on top of a capacitor, which kind of seems odd, but the control board takes direct voltage into it from power source, from your actual power source. All right, so the ADP control board will actually take the actual power and be like, oh, okay, well, it's this is how much power he's drawing. All right, well, there'll be, okay, well, since he's drawing this much power, the BIOS, so like another 8-pin kind of like this, the BIOS chip or in the drivers all talk together for everything, going, well, he's at this limit, he's at the max wattage, so your voltage times your amperage, he's at the max wattage, do not go past this. This is it, that's all you get. Adding on a 2R2, again, think of this as a 2R2, I don't have one right now on hand, on top of this capacitor, it will cut that voltage down like 1/20th. It's around 1/20th or 1/24th the actual power you're using. All right. So you can get a lot out of it, but a 2R2 from all the cards I've done it to, do not put the card into a limp mode. Its 2R2s are just perfect. You can get them off of donor boards. There's abundance of them from motherboards, graphics cards, from donor boards. Easy to get. What you want as little as possible is actually good. Nothing wrong with seeing very little. It's seeing huge dry spots. That's the bad part. And that's what you want to do though. For doing a piggyback onto a controller board. Technically, it's not a shunt mod because shunts are its own. Can I heat this enough? Pop off? Yes, it will. Let's go. Nice. Okay, I'm gonna re-prep that. So I'm gonna re-prep it. Just a little bit of flux. Voila. All right. So to all my normal viewers, sorry for continuously saying the same thing and that over and over. It's just in case new people join and You want to see like the technique that you should be learning to do this kind of soldering. That's why I've been saying the same thing over and over for like the past 6 hours. Yeah, it is what it is. And then shunt, so your shunt will generally be from, if you do have a shunt, will be from your, where's, wait, wait, what? Oh, oh, when I hit the camera, it moved it. There we go. So, from your 6 or 8 pin, it'll be right off of that, either right in front or close to it, and then you'll have another shunt. You'll have another shunt off of your PCIe. All right, and then that will be could be down here, low ohm shunt, low ohm resistor, or it could be on the other side. But generally, you generally will have them fairly close to your 6 or 8 pin. Like one here, somewhere else, over here. But these are caps, as you can see. I don't know if you can read it. C118. C is cap. Shunt will be a resistor, so there should be an R. I just don't see anywhere on this board where there is any shunts. Or any kind of silk screening showing. So there probably isn't any on it. Just go straight to a control board of some sort. So yeah, if you want to see anything get soldered, let me know. And go through the steps for it. I've already done a bunch of stuff over the last 6 hours of showing what not to do and do, what people end up with, like these blobs, which are no good, and showing how, like these ones here, how nice they look. Now you can basically get that every single time by following certain steps. So again, if you want to see anything, let me know. Do another. Can do another. Oh, some more cotton on it. Do another transistor of some sort. show what not to do, what to do for them. We can do another logic board of some sort, another 14 pin. Well, I was more caught on that one too. You get better Q-tips. Do an 8-pin logic board, you do a 14-pin logic board. They're still roughly the same. These ones here. That's what I'm talking about. 8-pin logic board or 14-pin logic board. I can go for any logic board really. Any. Or we can do a shunt. We can do a shunt. Shunts can be a pain in the butt. It's because they soak up a lot of heat. So L5 would be one. So we could do that over there in L5. Down here. See, L5. And what we can do here is prep it. A little bit of flux goes a long way. Clean up your soldering tip. We're gonna need a little bit of solder for it. A little bit of solder onto the tip. You just gotta run it over the area to add some solder to, and also to give nice new solder as well. And where's my shunt? I should have a shunt around here somewhere. Where'd you go, shunt? Where'd you go? Hello? Oh, right there. So we got a shunt. So what I'm going to do also is line this up on this. Move this a bit closer to me. And this. Like so. Like so. Like so. And we can do this. We hit these pads. Take a look at these ones here underneath these ones. And we can hit these with some new fresh solder as well. And we're going to need a little bit of flux by the looks of it. So we want not, I don't know if, I guess I'm not really showing it. One sec. We don't want that nib. We want that fairly flat. We want it fairly flat. So a little bit of flux. And then we clean that up. So, alright. Now the main thing with this, I know it's not technically in the correct spot for this shunt, but that's okay. What we're going to do, we'll actually move it over to the correct spot, because this shunt is a larger shunt for this one. Move that. What we're going to do is move it to the correct spot, larger pad for it. It's designed for it. That will be one of these ones here. Alright. So we'll add a little bit of flux to it. Not much. Again, same thing. You want to add a little bit of solder to a clean soldering tip. Alright. Boom, boom. That's more than enough for what you're going to be doing. We've already prepped this up. All right, we've already prepped up the shunt. So we got to line this up into the silk screening, right? Line it up. Line it up real good. Oop. Hold it down very gently. We're going to hold it to the one side. Now, there's a hole. I need my other tweezers. And then what we're going to do is hit the sides. So get this back into place here. We're going to hit the side and we're going to hold our soldering iron to it. All right? Hold it to it. Good thermal transfer to the side there. Just give me a second, I'll show you. Let's switch the board around here. Press down on this side. I'm going to hold it to the terminal again. Hold it to it, right where the solder is, and to the terminal, and you'll hold that to it. Alright, and what I'm going to do is add a little bit of flux to that. I'm going to redo that. Just to clean it up, make it look pretty. Now what I'm going to show you here is what happened. Right, so the idea of doing that, prepping it all, remember prep work is king for this. Now the terminal here goes up into this shunt and it just allows steady voltage to go through. All right, so this, even though our pads are down, our surface mount pads are down, what we're doing is, because we had that little bit extra solder onto the pads that we added on, and since we're adding a lot of heat to the terminal that's going underneath, and then we're also adding heat to the solder that's on the pads, we are soldering this to it. So it will solder to the pads underneath the chip, underneath this choke inductor. It will solder all the way down and solder to the side nicely. And I can show that to the other side. I'm just going to hit the other side quickly with some flux and another touch with the soldering iron, just to clean it up, make it look pretty like the other side. All right. So, got this. There we go. The other side here, hopefully you'll be able to see. Let's move the camera. It could have been a little bit better of a job, but still does the same thing. And how I'll do that, clean that up, is just, again, hit it with a little bit of flux, clean soldering tip, and we're just going to hold that to it to clean that up. And then I'm going to put a little bit of solder because it needs it on it. There we go. Go back up. A little bit better. And a little bit more flux. There we go. And that does the same thing. Nice solder joint to it. All right. And that's how you can solder. That's how you can solder a choke dash inductor. Fairly easy to do. Oh, okay. My end stream here. Oh, I forgot my coffee again. Oh my god. I can't. How do I keep forgetting my coffee? So we did do quite a bit of stuff today. Show what to do, what not to do, what to make it so it looks like all pretty. Got a whole bunch of subscribers too. 5 more subscribers to 1,400. Let's go. So, again, we went over how to solder your caterpillars, your little caterpillars. Well, actually, no, your centipedes, your caterpillars, your small batteries, and then like little batteries right here, little batteries right there. And then we also did a little 3 points. Showed how to do inductor, choke inductor, whatever way you want to call it. What else do we do? Well, I guess I did show how to do a surface mount tantalum cap here. I guess I did show how to do that. Just went over a bunch of techniques. And stuff you should look out for. Not too difficult. But I'll be back in a minute and probably end the stream. That way I can go relax. Might do more soldering video tutorials tomorrow. We'll see. Got a whole bunch of viewers. And the normals. Again, thank yous. Thank yous all for being here. So, yeah, your nicely done You got your not so nicely done, and this is basically no flux. This is no flux being used for this. That's why you get this. This right here is because you're doing way too much solder. Alright. Too much solder. Pretty good. Too much solder. Really good. Just give me a minute. I'll be right back. Alright, so if anyone wants to see anything, I'm going to be ending the stream here, so if no one wants to see any certain soldering techniques done to achieve good looking solder joints, not end up with something that looks like this right here, or like this here. Actually wants to see something that ends up like that, little techniques for it, let me know. Or anything else that's on the board that you might need a hand soldering, like your centipedes or millipedes, whatever you want to call them, and your caterpillars. I'm gonna be ending the stream. Does anybody want to see techniques on how to do some soldering on a board or no? So yeah, I can show you how to do these nice solder. So you're not ending up with something like this one here, or this one up here. Do a barrel roll. Ta-da. 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 Where's Matt? Where's Matt? Ta-da. There you go. Your hair. Come here, kitty hair. Do a barrel roll. Ta-da. Oh, oh, let's do a backflip now. Ta-da. Ta-da. If I had some masking, I can show how to fix up. Let's say like over here. And you're missing a pad, I could show how to fix missing pads. I just don't have any masking right now to fix that. It's a bit of a technique for that too. Some cotton from the Q-tip. Oh. Away the flux. Put away the flux if anyone does not want to see any more. Do another. I can do one more. me do one more here, right there, underneath the bad one there. Right in the stream here. So, what we're going to want to do is a little bit of flux, not much. Clean your soldering tip. Run it over these pads. Like that. You grab your capacitor, or whatever your surface mounting that's small like that. Could be even a resistor of some sort. You line that up. Right, line it up nicely. We're going to tack the one side. Doesn't matter how it looks too bad. Like, even if it doesn't look great right off the bat, you have a little horn or something, that's okay. We go to the other side. I'm going to tack this side too. That side turned out pretty good actually. What we're going to do is add a little bit of flux. And gently touch the solder to clean it up. Same thing with the other side. That's all there is to it. And clean up what you got. Clean up any flux afterwards. Ta-da! Ta-da! There you go. Nice, easy. Nice and easy. And just like that. That way you're not ending up with something that looks like this one. Not looking like this one either. But nice, clean solder joints that look more professional. Professionalism. I'm a professional. I'm a professional. They call me a professional. And I think we're going to end the stream on that note. So hopefully some people that joined in, they learn some soldering techniques, some do's and don'ts to not have certain looking anti-professionals. Sound like something else. There we go. Yeah, so that way you're not ending up with your blobs. A lot of people end up with the blobs. Some people end up with the bumpy. The bumpy's not the worst either. It's also not the worst, but the problem with the no flux issue is the clean. Let's say you're wiping around an area, like you're dragging it, right? It catches, and then you'll got. Let's see if I can. It catches a bunch of fluff off your Q-tip. Catches a lot. See all that around there? And if we go to like one of these nicer ones, like these nice ones down here, it doesn't catch. There's no catching. Doesn't grab as much of a. It's over there. That was there before. It doesn't catch the your Q-tip as much and destroy your Q-tip or make things a pain. Come here, you. I'm trying to use the screen for this. Come here, you. Come here. Come here. Again, I'm not used to using a screen. I generally just use my eyeballs for all this kind of stuff. It's just very new to me for the screen. Come here. I can get you. I can do it. I can do it. I cannot do it with those tweezers. I gotta grab my other ones. There we go. There we go. Yeah, that's one thing with these bumpy ones that you get. It's just it destroys your Q-tip. Absolutely destroys it. These other ones are really nicely done with no bumps. They don't destroy your Q-tip. A lot easier to clean up your area. And you can make a Q-tip last longer too. And then the blobs. I mean, the blobs aren't terrible. They just don't look good, and they're fairly easy to clean up, and they generally don't destroy your Q-tip either. But the blobs can also, you might not see it, but it could have some sharp points on the corners of the blobs. That see how it's actually grabbing some of the Q-tip. No good. No good. Same thing with this one here. This capper right here. It's got a sharp point onto it. And to fix that, this one might take a couple tries here to fix, but a little bit of flux. And we're going to hit it with the soldering iron on the top. A little bit of flux, because we have some of the Q-tip into it. Like so. And then we should be able to clean that up nicer, and it shouldn't grab. Yeah. Doesn't grab. Looks nicer too. Right? There's ways, and that's why flux, in my opinion, is very, very useful, and you don't need a lot. Just like this one that's, and a lot of people that aren't using the flux or anything like that can end up with this, and a little bit of flux, like that's it. That's literally all you need. A dab onto it like that. And you just grab your soldering iron, clean it up with the brass, and a quick little. And if you get this horn right here, you get a little bit of flux, hit the horn again. Ta-da. See that? Gone. Looks good. Then you do the other side. Again, try to make sure you have it in good placement for you too. I just switch hands. That's all I do. Bam. Alright? It's like that. Just like that. And you got a nice looking. A lot of people just, I don't know, they freak out on a lot of stuff for this soldering. They freak out. They just don't. Sometimes you might end up with something that doesn't look good. You can clean it up. Yeah, sure, this is still using a little bit more solder than what you would want, but it's still within the pad, still looks fairly decent. Does it look like one of these ones here? No, but this takes time to learn how to do it, like these bottom row. It does take time. And then you can technically clean this one up enough, clean your soldering tip. Clean it up, make sure there's no solder on it. You know, make sure it's nice and shiny, Add some flux to that, and just run it by. Clean up your soldering tip. Run it by, or you can do pull technique up, which is fine, but sometimes it will cause issues there too. That's why I like to do the pull technique on it. And there you go. See how you just clean that up even more? Looks better. More better. That's it. It's not. Main thing is having a steady hand. Prep work. Prep work goes a long way. Yeah, the full technique on the tip. Make sure you polish your tip. Don't forget to polish your tip. And to polish it, you just dab it in the brass, okay? And that's how you polish your tip. And what else also that I have and like to use is a brass brush. So that way, whenever you're fully done, you can rub it, and you can rub your tip with the brass brush quite a bit. So that way you have done, I'll show you here in a second. Alright. So you can clean the whole tip. The whole tip looks nice and shiny. It's all good. I mean, you don't need it to go all the full distance, but. And then after you're done soldering, you're going to add some solder to the tip. Alright? And put it away. Turn it off. That way, it's ready for next use. Exactly. Yeah, way more gooder. Tips. Dance tip technique, yeah. I do have another YouTube channel that I want to start putting some videos on. I'm just not sure what I want to do exactly for. I might do a channel strictly for soldering to show techniques just for beginners using cheap machines like what I have, just a cheap soldering iron and hot air workstation. But yeah, I do have another channel I would like to maybe start putting some videos on. Dedicate for, again, soldering. Yeah, down with the DTT. Yep. Again, even if you wanted to do, let's say, again, the blobs. The only thing with the blobs that is not great, like the blob, what I'm talking about, the blobs. The thing that's not good about the blobs here is they take a long time to fix. Okay? A long time. So you need to use some flux, and then you gotta clean it once. Look, we got rid of some solder. Gotta clean your tip. Yeah, gotta continuously clean that tip. Got rid of some more. I mean, not much. It's not much. And then we gotta do it again. Ah, it's starting to look pretty. Everybody likes a pretty tip. So yeah, keep cleaning that tip. Keep cleaning it. Over and over. Alright. Look at that. It's starting to get somewhere. Look at that. Oh my god, we're getting rid of that blob. Oh my god, we're getting somewhere. How many times do we have to polish our tip, you guys? I like to polish my tip at least 6 times a day. Actually, that's more than that. This is like 6 times just for one job. There you go. See that? How we went from this bubble to something that's actually presentable. 9, yeah. Now we're at something that's actually presentable. And then to do a finalization on it, you can just add a little bit more flux. There you go. Now you got something that's presentable. And then you gotta have to do the other side. That's if you end up with these blobs. Alright. So just don't freak out if you start having some issues. You can always fix it. You can always fix soldering, which is nice. So like, let's say we go over here to like these pads over here. And let's say you've dropped some solder onto it. Oh, wrong side. So you drop some solder onto it. Oops. Oh god. Oh god, what do we do? Oh, what do we do? What do we do? Oh god, what do we do? What do we do? Well, polish your tip again. No need to freak out. Polish that tip, clean it up. Grab some flux. Grab some of that solder. Clean your tip. Some flux. Boom. Oh my god, what? End of the world just because you dropped some new solder or something. Alright? No need to freak out. No need. You can always fix it. That's why making sure you're not using too much heat is also beneficial. Having flux is beneficial. A lot of people just get the core solder wire and with the rosin flux, or generally is rosin flux that's built into it, so it has flux into it. But you should always have yourself extra flux, just in case. You never know, something might happen and you might need to fix it. Squeeze, he needs help. Show him your technique. That's... I love getting extra fluxed up. Yeah. Then having a toothbrush dedicated for this kind of stuff too. This one's kind of melted, but that's okay. There you go. Now we can get rid of any extra Q-tip. Accidentally got this one a little close to the heat one day. So she's a little rough. A nice soft toothbrush works really good. JK? No, I don't think you are there, honey. I don't think you are. I don't think you are. That came out full-heartedly. All I'm gonna do is get rid of that melted point. I'm just gonna cut it off. Cut it off. Pretty easy. And like so, I just cut it off. And then we got a brush that we can use to, it's just more or less to get rid of Q-tip that might have caught somewhere. Could be old flux that it sticks to. This also helps show how good your soldering skills are. Yeah, get all that black gingivitis off the GPU. Yep. Well, it's also like because I use most of the time I use donated parts, right? Sometimes you might get them. They don't. They look like this, right? They might have some flux on it already, which is all right. And then once you clean it, like once you put it on the board, you can clean it up. Not a big deal. Not a little bit extra flux can help. It's not, again, not like it's a big deal. Even makeup ones. Yeah, and that's why I like different kinds of brushes for cleaning hardware. Not toothbrushes, but like different brushes, because some can get into better spots, take off certain dust too better. I have a really good paintbrush that I like to use, 3" or 3.5" paintbrush. It has like super soft horsehair. It's really nice. I got another one that's smaller, more detailed type brush that's a bit rougher of a bristle, but also still soft. It's really good for components. You say you've done all this squeeze, but you haven't shown any of it in the Discord. Are you sure you've actually done it? I don't know. So yeah. You go from bully, bully, bully to nicer. Oh, was it? Oh yeah, it was a while ago when you did the keyboard. Fancy keyboard you got to solder together. Most people don't have those or even use them. It wouldn't be too difficult to do. Maybe sometime we'll show how to do. They go on the side here. And over here. Show how to do. This one goes here, like so. Like so. Show how to do a small. These are annoying. These ones are very annoying to do. Unlike these chokes here, like this choke. These ones are not that bad to do. They really aren't that bad to hand solder. These ones can be a pain. Because the terminal that goes to it, focus, is right close to the end. It's not much of a terminal, so you have to make sure you're using a certain soldering tip. Because you got to hold to it quite a while too. So prepping your surface area is a must, and then prepping this as well is a must. Like, it is a must with new solder, new better solder. So when you put it on and then you're doing it, you have to hold the soldering iron right at the bottom, close, and you got to hold it there for probably like 10 seconds, right around 10 seconds, to make sure that when you heat up this component on the side down here, that this whole area around here will actually flow. The solder will actually flow. It can be a pain, and you can't really. There's not much, as I've shown. There's not much of an area. So these chokes can be kind of annoying. Inductors. These ones, in my opinion, aren't too bad. They're not too bad to hand solder. Prep work is key as well, though. Prep. You can do a good job for these as well. You had to add batteries to what? Yeah, you need flux. Flux is, like I said, I like to use 8341. Oh yeah. Oh yeah. Oh yeah, you can read that, can't you? Yeah, that's perfectly readable. Oh yeah. Still not readable. 8341 though. I've had this for a while. You can get this 50 mil 8341 no clean flux for a fairly good price in my opinion for how much you actually get and use. 8341. This stuff is getting old though. It is getting old. Yeah, do it yourself vids, yeah. Yeah, sometimes you need those tutorials or, how to. That's why I'm trying to do more of these videos for people, do live streams for people just in case they have issues with soldering. It's not as bad as what people think it is. Yeah. Steady hand is the main thing though. Steady hand and prep. Prep work. Your first YouTube tutorial was Windows Vista registry editing because a new PC I bought didn't recognize the DVD drive. Of course it didn't. I have to desolder all this stuff too. Desolder for another time, another video, another tutorial. Ooh, 3-core CPU. Was it one that you could enable the 4th core or no? The 9. Was it the 9? Some 900? Something like that. Someone, I think it was a 900 or 490. No, that's a 900. Oh, yeah, that's right. You were talking. Oh, yeah, I remember you talking about that. Yeah, it was a dead 4th core. That sucks. Uh, yeah, some was locked. Yep. And booth PC of my brother-in-law. Nice. Yeah. Of? That hurt my brain. Hurt my brain reading that. Was it at least a decent PC that you bought off him, or eh? Plus my typing skills. 99.9999% was your typing skills. Workstation, core to quad with the GPU. Oh, yeah, yeah. Is that the high the high frequency, the 1.4 gigahertz? I had oh, yeah, I had the Q8800. I think it's the 8800. It was on DDR3 board. Oh, no, that was on DDR2 board. It was on DDR2 board. I wish I had a DDR3 board for it though. I don't think I have that one. No, I don't have that one anymore. That was in another PC that got lost in the move. I should have kept it. I should have kept it, but I didn't. Cha cha cha. It's good. It's real good. Especially have some good ICs for it. Good RAM ICs. It's very good. It's very good. You basically get fairly close to the same latencies on DDR3 as DDR2, but faster, more bandwidth, faster frequency, which is really good. Close to the same latencies on it. Pretty good. Pretty good. Look at it. Clean the brass. See what the inside looks like here. Oh yeah, we got a whole bunch. That's how much cleaning I did, and that's 7 hours of soldering there. Cleaning the tip all fell out into there, and then there'll be a whole bunch in the brass that I'll have to scrunch up a bunch of times into a bag to get rid of it. Yep. Yeah. Because you'd be doing like 1600 with really good timings. And then with certain ICs, 1800 with insane timings. Like 1800 CL6 or 1600 CL5. Very rare case that you will get CL5, but CL6 generally. With low TRFC. Like around 65 to 80 TRFC, which is also a gainer for that, for performance. Yep, yeah. We should keep the CPU ahead. OJ sensitive. Yeah, yeah. A lot of people, they don't. Yeah, DDR though. Yeah, that's basically DDR. DDR2 or 3. It's insanely good latency. That's why a lot of the like old railroads and that still use that stuff. Low latency and it just lasts. Oh, I always wanted to try out a Q90 550. Yeah, definitely try it out. Should be pretty good performance increase on it. Yeah, clock speed and also once you go to like the 8,000, 9,000 architectural upgrades, slight upgrade per core advancement on it. 18 bucks. And there's still that much for a Q90 550? Wow. Yeah, the X chips are not cheap, man. Those X chips still are not cheap. They're not cheap at all. How many phase? How many phase VRM is your board? Isn't that a good board, I'm guessing? Oh yeah, MATX. Yeah, MATX. Not the greatest. Just not great. MATX, even if you have high, like a decent VRM on it, they get hot on MATX in my opinion. Not worth it. Everything's too clustered up. They generally have things too clustered up, not built well. The MOSFETs just aren't there. They use a lower grade MOSFET, like a 60 amp or 45 amp MOSFET, and some of them even will use like a 35, but it's generally 60 amp or below. Not your nice 80 amp. Yeah. There's some techniques for soldering on different components. A bunch of different components on what to do, what not to do. Anyone that's just joining, these are showcasing different kind of variations that you can get on these, and some nicer with done up nice with certain technique. So if you want to learn a bit about how to do this kind of soldering, you can go back in the live stream or watch the live stream after I'm done here and go through. Yeah, just make sure you know, you got some good airflow on the VRM. You should be able to see it though. Not, you won't be able to go, ham with it, but make sure you got good airflow. You'll definitely be able to OC it in wintertime when you do your chilled runs or your cooler runs. You will be able to. Good airflow on the VRMs, and you should be just fine. The board has heat sinks on it, right? I'm guessing the board would have some heat sinks. 660 Ti. Yeah, I've been looking at eBay on some graphics cards, and some are seeming like a decent price. I need to get some more GTX 770s. 780s actually aren't terrible price either. Oh, so it doesn't have any heat sinks. Yeah, definitely add some heat sinks to the VRM. Definitely do that. Yep. Okay. They should have a South Bridge and North Bridge cooler. They should. If not, it'd be kind of wild that they didn't have one. As the South Bridge will get hot. North Bridge not so much, but the South Bridge will get quite warm. Yeah, those HD 7000 series were not half bad. Those are pretty good cards. Yeah, if you had a PC like that, yeah. Because even like the HD 7770 there, that's like a GTX 1050 Ti roughly. And some cases outbeat the 1050 Ti from at least going off of memory. In some cases, it was better for some games. Yeah, if it's and it will run warm. That's it's just your South Bridge will um can get quite hot, especially when you're starting to push it. Is it? I'm guessing the South Bridge has a better cooler than the North Bridge. Has it a little bit bigger of a heat sink? What are you doing with that PC? What are you doing with it that you need to make sure you're, pairing up the CPU with the GPU properly? You're not doing it for overclocking? Ugh. Want to build a PC like that back in Modern Warfare 3? You came out. Oh yeah, yep. Or it's using that old terrible paste. Oh, gotcha. Yeah, definitely run some tests on it. He's only gonna probably play esport games, I'm guessing. So most kids usually just play esport games. Yeah. Yeah, back then, yeah. Because back then with the Intel CPUs, man, the performance was big gains as soon as you went to an Intel CPU. You did spend a little bit more, but it was a lot better of gains architectural wise. It looks so much better. Yeah, little games that don't require a beefy GPU or even a beefy CPU, really. Yeah, from that era. Yep. That's roughly the era that if you have that kind of component, was the Xbox. And it would outdo the Xbox technically. The 660 Ti will definitely outdo it. Alright, just give me a minute here. Yeah, still 120 hertz at 1080p for a TV is still pretty good in my opinion. Yeah, still decent. Definitely still decent. All right, I said I was gonna stop this stream like almost an hour ago, so I'm gonna end the stream there, guys. Anyone that's just joining, my bad. Probably do some more soldering techniques for tomorrow to show how to do some soldering. Um, make them look nice and pretty. Yeah, up above 120 FPS is nice. Above 120 you don't need, but definitely nice to have. So again, thank you everyone for joining this stream. It's not exactly the most thrilling thing to watch, but to show some techniques on stuff, it's trying to do some more helpful videos and live streams for people. Yeah. Hope everyone has a good evening, and we'll catch you on the next one. So again, thank you to all my viewers, subscribers, and donators. You guys are helping out this channel more than you know. Again, thanks for watching, and as always, don't forget to get her done. Peace.